Mr. Gabriel, how are you?
I'm fine, Mr. Taka. Welcome.
Gabriel, how are you?
Fine, Mr. Taka.
I hope
Welcome.
you are busy with the project.
Yes, I'm
If
here.
you're not busy, then I'm afraid.
What?
I'm saying if you are not busy, then I'm afraid.
I'm very busy with
Should
design. Yes.
Should be busy. I think you have finished light and power. You have finished fire alarm and power. Because those are straightforward.
Light. I was doing light and power. I thought you are also doing light.
In different files?
Yes.
Okay. Can you share your screen so we can see what you are doing?
Yes.
Gabriel, how do you have one light in a master bedroom? Hello? Can you hear me? Gabriel?
Yes.
In the bedroom below there you have one light.
Oh, I'm going to add them.
And what does D3 mean?
Downlight.
Of which capacity?
Not set yet.
No, internally for you, it's which capacity? Because we used D1 in the example yesterday, and it is 22 watt, if I'm not mistaken.
Yes.
So your D3 is having which capacity?
Oh, I have not calculated.
How did you place them without calculating? How did you know that you need four lights, or one, or two?
I did mistake here.
I'm saying, how did you know that you need 2, 3, or 4? You based your calculations on what?
I think I did mistake on calculating.
Gabriel, there is a procedure of
Yes.
there is a procedure of designing the light, and I explained it yesterday very well. I think everyone was with me. Gabriel, you're not responding to my question. You based on what to put light in those areas? Yesterday I shared a plan of types of lights regarding locations, and I shared the document with you. Did you read it?
I read it.
Did we plan to put a downlight in the office?
Yes, this one.
Was that the plan we had?
No. I think we didn't do it.
Can you open the file that we used yesterday? Can you open the formulas that we used yesterday and refer to them while you are doing lighting design? And I said yesterday, focus on power and fire alarm. Then you end with light, because light is a bit tricky. I'm seeing you're putting everywhere D3. D3 should have a meaning. It should have a capacity. If you have different downlights, they should have different names. If let's say D1, D2, D3, and you say D1 is this capacity, D2 is this capacity, not putting everywhere D3. Because yesterday in the sample room that we used D1, and D1 has a specific characteristic.
Okay. Let me cancel this lighting design.
I'm not telling you to cancel, just make sure you understand what you do, because After this training, you will be alone in the field. You know, you have to explain to people why are you doing what.
Okay, sir, I have understood my mistakes. I will correct them.
Gabriel, can I see your light, your power, and okay, I can see this is fire alarm. Can I see your power?
Yes.
I said consider a TV in front of each bed and put a socket there. I wanted to show people how to do title block, but some are not here. Sorry?
Teach us, we'll teach them.
Friend, where is your power? You should finish everywhere. Did you work on this after leaving here? Sorry for you. I will give you a half certificate.
No, I'll finish it. I'll finish it.
When?
Today. Okay.
Then I'm adding some more items to work on.
I'll run it there.
In French they say, à chaque jour c'est plus à peine.
I'll run it there.
Let me let you know French.
Comment?
In French they say, à chaque jour c'est plus à peine.
Kisuma nasema nakuwa itakuwa hiyo.
It's possible. Because they like to. Yeah, that is the efficiency of the light. Sorry? Yes. This is a group of light. Specific ones are here. This is a group of light. And this is only for downlight. If you are choosing something else,
You are choosing something else and then you get to the group.
take from here. See different watts are also different capacity.
Jina. Safi, that's good. Mambo yanaenda. Ndio. Ndio. Okay.
Sitting room, eh?
Ndio.
Aha. Elfu moja mia nane hapa.
Sawa. Sawa, kwa tuzimani. Okay, sawa. Nimeona. Okay. Yeah. Haina neno, nimeona hizo pointi. Nasema nimeona hizo pointi. Acha tuzifanyie mambo. Ndio.
Ipo lazima. Sio ukija utaona kuna suka profile ya bomba kwa ajili ya kuvuta haya. Pale lazima pale. Pale unatafuta chandaria fulani nzuri.
Gabriel, there is no TV point. By TV point, I mean a supply for TV. Just put a double, a twin socket there. Okay?
Okay. Okay. Okay.
Hope Gabriel, you can hear me. I'm saying by TV point, I mean a twin socket for supplying the TV. There is no TV
Okay,
point
okay.
like the way you are doing it.
Okay. Okay. Okay.
Mr. Rama, can you share your screen? We need to see your progress. Gabriel, stop sharing your screen. We need Rama to show his screen.
Okay, let me join on Zoom on my other device which I was working. Then I share. I will share, but I'm not doing much because the last session yesterday I was not there. So I'll share what I'm starting to do now. So
We need to see your screen, please. But also, yesterday I told people to ask me questions in the group. No one asked me. Huh? This is where you are still, my friend.
no, yesterday night I'm not doing anything. So it's difficult.
Why you did not do anything yesterday?
I have something more, from 2 p.m. we have something, I'm at your site. So from there we have the meeting, then we have a lot of
Yes,
job
but we
sites
did
to
something.
do.
We did a lot in the morning. All the lighting, we did it in the morning. Did you finish it?
What I'm saying, from 2 p.m. yesterday up to this morning, I didn't get chance to make the review for what
Okay,
we
show
learned
show
in
us
the morning.
what you did in the morning. Show us what you did in the morning yesterday, because we finished all the concept of lighting yesterday in the morning before 2.
I have that problem of exploding because of the AutoCAD
my
I'm
friend.
using. It's not what you have.
You are talking about not being available from 2. You are now talking also about AutoCAD. Does that stop you to put light in the plan?
I'm supposed to put that light at the night, but because last night for another assignment to do, that's why I failed, because I'm not following what you are doing during the training. That time because of this problem.
My friend, if you have challenges of working during the work time, take your night and work on stuffs. Eh?
What you are saying?
Who is supposed to work at your place?
Who's supposed?
Who's supposed to do your work? It's not you.
It's me.
Yeah, we are going for circuiting now, and you don't have anything. How are you going to work without having any design?
I will try my level best. I can manage it. Maybe I can do all day after. When we are finishing circuit, I can do lighting, power, and everything. Then
you think you'll finish today?
I will manage this.
My friend.
Then evening I will give you.
Okay, it's up to you. Me, I did my part. If you don't want to follow, then it's fine.
I will follow.
But yesterday in the evening, I said, who was a challenge? No one spoke. I'm
told that night I have another assignment to do. That's why I have no time during that night.
Yeah, but
that's why I say.
Since morning, what are you doing? Because we are 9 now. Since morning, what are you doing?
Since morning, just I'm preparing the drawings so as I can put lighting, power. Since I come to the office, that's what I'm doing.
Where are the symbols? Where are they?
I just take this symbol, so I wanted to export them to use that.
Mr. David, I'm concerned about people who are very far behind, and I'm not sure if they will be able to catch up on what we are doing and be able to finish their projects by tomorrow. Now soon we're going to do title block, attachment, and all the information in the title block, so people can be able to print and upload their drawings. People who will be behind, I will consider them not on track, and if they are not able to finish the project tomorrow, I'm not going to take responsibility of that. That should be very clear.
No
I think
problem.
I think David is listening to me. Okay. Let's take the power drawing. Are we all together in power drawing? So we have all saved the title block in the title block folder. Don't follow this. Just follow the procedures, regardless of your step where we are. Just focus on what you're going to do. Don't focus on start putting the PowerPoint. If you are doing a training of software and they're leaving you behind, it's better you catch up on what they are doing. Okay? You might find someone flashing power socket now while we are putting a title block. You can still come back on that and do it by your own. I've sent a title block to everyone. Do you have it? Yes. Did I put it in the group or I put it in the drive? I sent it in the group. Download it and save it in the title block folder. Can you open the title block aside as a separate file? Follow what I'm doing on the screen. Open it as a separate file and make sure the settings are as we are expecting. So we try to do units. No, open it as a separate file. Just open it as a normal file. We are opening title block. Open it as a normal file. Where title block is saved, open it as a normal file. Go and open it in the folder where it is saved. We are trying to set as put it in meter. Are we all together, or some people are behind? Are we together or some people are behind? Sorry? You said what? Set the unit in meter. Sorry? Yeah. Are we done? People online, did you set the title block unit in meter?
Yes.
Is it saved in title block folder or it's saved somewhere?
In title blocks folder.
Are we all here? Are we all done for that process? We're going to attach the title block. So what we do? Let's first set the parameters of the layout, as I was explaining yesterday. So if you come here in the layout, now let's see if you're not able to see this this coming, just come here and do page setup manager. Come to layout 1 and click right. Page setup manager. Are we all here? Okay. So we do modify. Are we all here?
Yes.
So this is the, are you here? So this is the, these are the plotting mode. Like there are different ways of doing the printing. You have some printers, you have some transformations, but we will take this one, DWG to PDF is the one we are going for, because we want to transform a DWG into a PDF file. So that is the one we are taking. Here we choose the size of the paper. You need A4, A3, A1, A2, A0, it's up to you. But to make your drawing more visible and have a possibility of printing it, you go for A2, A1 or A0 format. But for us we choose A0 or A1. Let's take A1. Let me check. So there are also different A1. But I'll just take the ISO full blended. One of these two. One of these two. You can take one of these two. You got it? Did you get it? Yeah, just pick one. So you come here to what to plot. So are you plotting a display? Are you plotting extent? Are you plotting the layout? Are you plotting a window? So a display will just plot what is displayed here now currently. So if you zoom in and you have only a small part of the drawing which is displayed, that is the one which will be printed. Extent, the layout, it will print the all white paper. You have seen a white paper. There is a white paper here, this one. This white paper, that is the one which will be printed, all this white paper. That is the case of the layout. So for the window, you choose yourself the area that needs to be printed, and that is mostly the easiest one. So let's say we have layout. This is the one by default. So here you have a possibility of choosing an offset of origin. By default, you keep it like that. Yes. Sorry? We are not yet there.
Okay. Let's get it.
We are not setting the title block. We have finished title block. We are setting the layout.
That guy gonna put it. See, and that's it.
We are not yet. We are not investigated on title block stuff. We have closed that file. We are not seeing this. No problem. People online are on call. Gabriel.
Yes.
Are you talking to us?
No. I'm just waiting for the progress.
Okay. So scaling here is always a 1 by 1, no need of changing it. Here you have the unit, 1 millimeter equal to 1 unit, which is good. So this is very important. I need your attention here. So let's start by the easiest one. Both. I'm explaining something on screen. So you either choose landscape, orientation, or portrait. I think you guys understand this. So for landscape, it is this orientation. The big part of the paper will be the horizontal one. If you do portrait, the big part of the paper will be the vertical. I think we all know that portrait and the landscape, you know the difference. So we go for landscape. Here, please pay attention here. They are saying plot options. Plot options means what are we considering for plotting. I will show you how you can navigate different size of lines. Like sometimes you need to have a big line in terms of thickness. So you see this one here, this command here. This command here in AutoCAD helps you to highlight each line with its corresponding thickness when you are doing the design. But the fact is, regardless of their size, if this area is not thick, all will be printed with the same size. So it will not consider the thickness differentiation. But when this is thick, each line will come with its thickness when you are printing. You can also set a transparency. Maybe some lines you don't want them to appear at their maximum transparency. So like you put a transparency at 50%, means the line will not be that visible. So when you tick here on plot transparency, it means you are telling the software to consider your parameters, each line with its corresponding transparency. So that is the meaning of this command. So if you untick it, it means all the lines will come with a common transparency, which is 0. It means all will come with their full color. So here you have plot with plot styles. Plot with plot styles mostly is this one here. Like there are different plot styles that are here. We are going to go through.
Sorry, engineer. Yes, for this transparent, can you clarify all, because you mean the line you use it going to be more light, or what you mean? Because I'm not clear.
You understand transparency, right?
Yes.
You understand the meaning of a transparency, okay?
Yes, I understand.
So when you are drawing lines, you might set different transparency, saying I need this line to be more transparent, or this not to be transparent. Okay, but by default they all have 0 transparency. It means they are having their full color. They are not transparent. But if in your design there are areas where you have set transparency and you tick here, it means when you print, each line will come with its corresponding transparency. That's the meaning. When it's not stick like this, all the lines will come with 0 transparency.
Understand.
Yeah. So here I was explaining now. Guys, please get this right, because if you don't understand it, it will be complicated for you to navigate printing. It's very important. So I was saying that here we have the plot style. So by none, it means each line will come as it is supposed to be. No, there will not be any change. So like all the lines will come the way they are on the drawing. Green ones will stay green, blue will stay blue, black will stay black, because when you are doing printing, there is a way you can say, I've done my power items in red, but I need, when you print them, to become blue. There is a way of setting it here. Or all the lines, I want them to become black regardless of their color. Make them black. So you have this is none. By none, it means nothing will, everything will come with its natural color. As you are seeing it there, we had some green point, we had some red. Everything will come as it is there. So now when you go for some printing styles are default in the software. Like for example, this grayscale. This grayscale is a default printing parameter in the software. So grayscale means all the line will become gray, regardless of how they are. So even your circuit, everything will become gray. So if you come here to monochrome, monochrome is white and black. Everything will become white and black. Now you have a printing style called Nziza. So it means each company has its own template and a printing style. Here, if you do you do Nziza CTB. CTB is the extension of the printing style. You can even send it to someone. You can send him your printing style. So what I want to show you here in the parameters, you are able to set. You see, they are saying black color. Sorry, this red color will become black. That's the meaning. So all the the meaning of that is in Nziza, boss. Sorry, you don't have it. I'm just showing you. You want to have Nziza? Yes, you can create it. But I'm just explaining that in Nziza CTB, all the red color are black. So all the red color will be printed black. So all the yellow colors will be printed blue, you see? All the green color will be printed yellow. It's just parameters. Sorry? Yeah, the meaning is that you might have a preference on design and a preference for printing. They might tell you, we don't need color of the drawing, just print what, black and white. So maybe people who are going to read your drawings have sensitive color control, and they want just things which are white and black. So you keep your good colors as they were on your design, but when you are printing to give to them, you print just black and white.
On drawing, but on printing, yes, white and red.
No, this is the preference. It's like you are cooking and you want to put salt or sugar or milk. Yes. So the software gives you that possibility. But there are some reasons. You know, sometimes, let's say if you are printing and you say, for me, red color is the best one on the printing paper. But I need to have them differentiated in my design, like how I need to have blue, black, and whatever. But when I'm printing them, I want them to all be red, because that is how it will appear better on the drawing. Like the software just gives you a possibility of changing and have that possibility. Yeah, it gives you that flexibility. Yes. But sometimes you see you have red here, and then they say use object color. Use object color, it means it will keep the same color as it is. It's just up to you. You can choose it or use object color. It means all the green will be still green. All the this will be this. Then you might confuse. There is a difference between this color 1, you see it's red, and this color 10. It seems to be red, but in the software it is a different color. Sorry?
Like,
No, you are not obliged to go for this stuff. You can just choose your none here, and you'll be in peace. No one will come to compromise you. So you see, you have all this color. You have 200. You have 255, and you can choose on how each of them will be reflected. Yeah. So I think with experience, you will see the meaning of choosing different colors when you're printing. You might say, I have 5 colors on my drawing, but let me just keep 2 or 3 only when I'm printing. Then you go for it. Yeah. So let's keep none for now. We have understood this one. We have the quality.
Sorry. How to create this, like what you show at Nziza CTD? How to create it?
You can do new here. You can create a new your own layer and give it your name.
Okay.
Or the name of your wife.
I see. The name of
your wife. Yeah. So we have it that way. What next? Just click on. Let me see. So click on OK. So what else we can do is to modify, guys. There is also a possibility of modifying the name of this layout. It's not mandatory to keep it as a layout 1. You can name it, as we're going to print ground floor there. You can call it. You come here, click right, and come to rename. You can rename it ground floor. So it will be obviously ground floor power because we are in the power drawing. But for people who have mixed their drawings, they can call it ground floor power. But for us, we're just going to call it ground floor. So we'll know that we are going to put here ground floor design. So next step, we are going to attach the title block. Click right, rename. Click right on this layout, then go to rename. Call it ground floor. No problem. No problem. Are we together? I can even delete mine also, so I can be like you. Let's be the same. So what we do, we are going to attach the title block. We go to insert, attach. We go to the title block where it is located. For people online, are we together?
Yes.
Where then and make sure it is attached.
Okay. Are we all here? Are we all here? Eyo. Eyo.
Yes.
Eyo. Are we all here?
Yes, sir.
We all here with the title block. So we select it. Are you here? Are you here? Open. Are we here? So we'll specify, no, the scale is 1. We'll specify the insertion point on the screen. So when you click on OK, pay attention of where your cursor is going, because the title block is very small. We need to scale it. Come and place it here in the corner, somewhere here. Hope everyone is doing what I'm doing. The block should be somewhere there. It's not shown. Did someone see the title block?
Me, I see the title block, but it comes somewhere in the very big compared to the dimension of what we set it.
It comes very big.
Yes.
Okay. If you have seen it, it's fine.
Huh?
If you have seen it, it's fine.
Me, I see nothing.
Mine is here. What I have to do is to bring it down on the page. Sorry? This is the title block. This is the page where I should bring it. It's here. Yeah. So try to zoom out and select the whole area. You might see it somewhere. So let me show you what I'm going to do. And then if you have a problem, you can verify it for me. So the first step I will do, I will select it here and come to home and move it down to the page. I'll first move it down. Let me come. I'm saying for people who have seen it. It is even fitting directly with my paper size, because this title block is A1. I have it there. So we are attaching it the same way we did for Guys, please, hello, can you hear me? Hello.
Yes.
Yeah? If you are busy doing something else, I'm explaining my stuff, then you come back, start asking questions. It's not good. We are in the power drawing. There is a layout called ground floor. That's where we are working. If you are doing something else somewhere, I don't know what you are doing. Tulifungula title block, tukaiseti mumita, tukaipost. I don't need to sit open in your part. It's like an X-ray. That is what we are doing now. Are you in a meter? Do you have a layout called ground floor? Then start the process. Otherwise, I would be confused when I'm coming to find. I will see different stuff so that I don't understand.
So I'm not getting that title block inside the model.
Gabriel, can you share your screen? I want to see how it looks like. Then Rama will be the next. Yes. And why do you have 3? Let's proceed. Both. How is it? Gabriel.
Yes, Mr. Taka.
I can't see anything. Go on ground floor. Ground floor power.
I have succeeded.
Ah, congratulations.
But it seems that I have bet. I don't know what to do it again. That's why.
It will come with time, no problem. But you have done this yourself. Then you'll be able to do it continuously alone. This is very good. Okay.
Okay.
What about Rama? Did you succeed, Rama?
No, let me share my screen. This is what will come on when I finish the exercise. It's come too big.
Can you delete this? Click that one. Click that line.
Which one? This one?
Yes, that's the one which is just yes, that one.
So you ask me to delete.
Zoom out. Zoom out. Zoom out. Zoom out. Zoom out. Delete it. Delete that one. Yes. Go up. Go up where the other title block is. The one which is shown.
You're going to lose it because it is far from. I don't think if I can see it again. Let me try. It's disappear.
Select the whole area. You see something in blue, and then you go for that. Select the whole area, then you go for some. No. Yes. Select the big area from the top corner. Zoom out, then select the whole area. Zoom out first. And then you select from the top corner going down. First secret to succeed in a training of a design is to know how to manage files. If you are not doing it, it will be confused.
So because I'm failing for lighting design, that's why I'm suffering now.
No, this does not have any relation with lighting design. We are setting a page. It doesn't have any link with lighting design.
I think it disappeared totally. Maybe I can redo it.
Go back. Go back. Undo. Undo. Don't type it. Go to undo up there. Above, close to plot. There is that, yes. Not there. Not that one. That is save. Undo. Just flow above there. Go right. Go right. No, above on the top. Close to where you before. Undo. You see two. We see something with a direction. Above on top.
Yeah, I see.
Top.
It's already come.
Yes. So zoom out. Okay. Take that. Select that title block.
I think maybe let me delete this.
Don't delete that one. Don't delete that one. Select the title block. Click on it. The one above, the one in inside. Not that one. The one inside. Not that one. The one inside.
This one. Yeah.
It's your problem. I've done it wrongly.
So maybe I can repeat it again.
You're even in the wrong file.
Which wrong file?
We are not working from title block. We are working from power. Where is your power drawing?
What we are doing now just to make the title block. So just
No. We are working from power drawing, not title block. Title block, we just set the unit in meter and we closed it. These stuff we are doing there are not the ones.
Okay, but I know the procedure. We can proceed. I will try it in my own.
You'll try it when?
Today now.
Power drawing? What is the power drawing?
I told you I didn't make the even light or power drawings.
It's not to make, to have it, to create it. Just save as we did.
You want it to save it now? To save it now?
My friend, it's up to you. It's up to you.
Okay, no problem. I'll know it out.
So up to now, you don't have anything to present. Okay.
Today is not a good day.
No, it's not about that, my friend. We are finishing the training tomorrow. Okay, it's up to you. I mean, I just did my best to support you guys. For people online and people here, I'm saying the first secret of this training is to follow the way of managing files. I explained too much time. Follow these steps. In the X-Ref, we have only 3-story building plan. The one I've given to you, I think before yesterday or I don't know when. You see, in my master sheet, I only have fire alarm, lighting, power, and this template. Only that. And this one we have is the one we started working on. I don't have anything yet. The exercise we have here is the one we did when we were starting to do training. In the printout, you see, I only have printout. The printout of the symbols, the printout of power and fire alarm. If you come here in my title block, I only have one file, title block only. In the symbols, I only have symbols as we were doing them. In the detailed here, I have the files we were using yesterday. As simple as that. But now if I find your X-Ref is in the printout or printout is in the symbol, we are going to be confused. Okay, let's proceed. Saying that we are in the power drawing. So what we're going to do, we are going to now make a space for where we can work. So what we do, please follow, please be with me. We do a command called mview. Okay, are we together? Mview. I'm explaining stuff, people are making noise. Ask me a question. Yes. Sorry?
in the layout. I'll show you. Even not
You're not? Are you in the power drawing? Eh? Yes. Do you have power drawing open? Do you have a layout called ground floor? Is your layout in A1? Did you lose this step? Follow the screen there. Right click. Use this mouse. It's not working. Sorry. But you will be slow if you don't have a mouse. I'm saying you will be slow if you don't have a mouse. We are going to wait for you. Let me do the settings of this with people who are behind or people who do not understand. So I'm creating a new layout. As you can create any random one. It's called layout 1. So come here to the settings, do page settings, then modify. In modify, you choose the type of printing, is DWG to PDF. You choose the size. You come to ISOFlow blade A1. Do it with me, my friend. I'm explaining it to you. Other people are very far behind, are very far above us. How are you expecting to scale without a mouse? Sorry? So DWG to PDF, guys, don't make noise, please. Follow the screen. Follow the screen. Both. Follow the screen there. So choose A1, this one. A there. First do this. Do first this one. DWG to PDF. Then come here to the page, to the paper size. Do this one, A1. Take this full name. ISOFlow blade A1. They are different size of A1. Some might be a bit smaller. You'll see some some contours here. So what to plot is layout. Here it's 0, scale is 1 out of 1, both. So the plot style is none. And here we are in the landscape. Then OK, then close. Then you attach the title block. So you don't need. Please follow. You don't need to attach the title block as much as we're creating the layout. Okay, if you have attached it once in here in ground floor, we can just duplicate this. Are we together? I'm saying you don't need to attach the file, the title block as much as you're creating new layout, because here we'll have ground floor, you have first floor, you have second floor. So what you do, you just come here and you duplicate this, so it will become a second one. You can just rename it. So can you do the same exercise? Let's first analyze this one, then we'll be able to duplicate. Okay. So what we do here, add some key information. Revision is revision 0, and come here to annotate. Revision 0, and make sure you are doing it in a 0 layer. Make sure your 0 layer is the one which is on. Date of today. You can follow from the second one I'm doing. Annotate here. Make sure you have the layer which is 0. Come here to annotate. Then create a space here. Put the date of today. So today we have 6. Six is 2, 2025. Okay. And here for the title, you can put we are in power. we can let's say design for work permit. Work permit request. Just an example. Let's say we are doing this design, request a work permit.
Safi.
Pole na kazi.
Asante. Kumbe jana ulikuwa huko siku nzima? Msibani.
Nilikuwa msibani siku nzima. Ni parefu.
Ni mbali.
Ni mbali. Alafu njia mbaya baba. Nusu kidogo gani mbele.
Pole hapo. Safi sana.
For people online, I wanted to say something very important. Normally, this is the first steps when you are setting up a project. All these steps of creating files and setting the layout, putting all this stuff. These are the first step before even start designing. Because at any stage, the client can tell you, send me your update. You'll not send him an update without a title block. So the first steps are these ones before even starting to put the objects or the symbols in your drawing. So these are the first steps. So finish this one, then we'll do duplicate, then we'll be able to start printing. I'm expecting that before we go for the break, everyone will print his drawings and save them on the drive. I'll give you the link of the name of everyone, so you can share with me your progress. And now at midday, I will tell you to update whenever you finish a drawing, you just go to the drive and you update it. So finish this information. When you finish, we will create a AM view here. Then we can start duplicating. People online?
Yes.
Gabriel, can you share your screen?
Yes, I can share. Okay.
Don't forget to save. And you can write down key steps. Don't keep them in your head. Yeah, this is very good. This is very, very good. This is very good. Can you zoom out? Yeah, we are still going to work on that the other area where we put a drawing. First finish this information, then we go for the other area. Sheet number, not sheet name. Just name it 1. Drawn by you, checked by me, approved by Nziza. Okay, and then you put the date of today's scale. We'll put it after. Revision 0. Okay, I want everyone to put his name in the group, his full name. I want to see them because I need to create folders of your names on the drive so you can put your files there. Can everyone type his full name in the group? WhatsApp group now, please. Type your full name in the group. I want to create a folder. Please create your group. Put your names in the group. Mr. Rama, share your screen. You want to see your progress? Mr. Rama, please share your screen. Gabriel, stop sharing. This is very good, but be a bit faster. We are 11 now. Would have been very far. Rama, share your screen, please. Want to see your progress? Mr. Rama, please share your screen. We need to see your progress. Mr. Rama, please share your screen. Okay.
Mr. Taka,
Let's
Mr.
proceed.
Taka, Mr. Taka.
I think is now we're a bit clear. Okay, guys.
I'm very sorry. You know, I'm got some emergency. Some people visiting my office and I need them to attend. So I just 5 minutes. I'm out of them. Someone calling me. That's why I'm calling back. You know, I do two things together. That's why these 2 days to me very difficult. I was of quite some issues, and this one I do myself. It's not just assigned from my office. That's why I say I have this problem. So sometimes I depend much to review the recording material, which can help me for future for doing this work. So these 2 days to me it's difficult. You see, as if I don't like to attend full, but because the assignment of the office. That's why I will not manage to attend it physically, and I requested to attend online. That's the problem I suffer now. So even now I need to attend someone, but someone calling me. That's why I come back. So I'm sorry.
So let's proceed. We are going to have something here. I'm expecting that you guys have filled all this information. Next step, we can continue after. So next step, we are going to create an M view here. We're going to create a space of where to display the drawing. All of us are in ground floor. I don't want to find someone who is in title block now. So we tap M view. Are we all there? Enter. They say specify corner of the viewport. Are we all there? So you take it from the corner, because it should be something that starts from above, from here coming down like this. So you click here, then you have this appearing like this. So this is basically where we're going to put the drawing. So we're going to focus only on ground floor. So there are two ways. Some people, maybe they have already known their scale, and they can scale this paper directly. You see here we have a scale. This is a bit tricky. I need to check it sometime. No problem. So what we are going to do, make sure this drawing is fitting like this drawing. This drawing of ground floor is fitting in this available space, because down here we're going to put also the legend. That's why I kept it for that. Or let's say another way we can do it. Unfortunately, it is not going to work with light, because light has a lot of items. Let's keep it that way. So let's have this ground floor fitting in this space. Then we'll have a space down here for the legend. Do you all have this one? Do you all have this? So if you come here, you double click in this space inside, you're able to move around. You can scale up and down and make this drawing fit the available space. Like this. And even cut it like this. So you have the drawing. This is ground floor power. You can push it a bit up above. I'll first reduce this one, make it closer, and then push it up. So what we do is the available space remaining down here. Sorry. So if by any chance you have such situation, it might be confusing. Come here and go to restore layout. So we come here, we create another M view for legend. We do the same, we zoom in. There might be more treatment that we need to add. This is just a way of showing how it should be. This normally was a double pole switch. There were no need of saying it's for the AC, because it's also supplying the hot heaters, the hand dryers. Just put double pole switch. So I can configure this, do copy, extend, coming back here, ground floor. I have this situation, take it back. Something to do. Something to do, because now you see this layout is under this line is under zero layer. This one also is under a 0 layer. So if we are all here, let me show you how we now print to make it a PDF. Please follow. Please follow. Please follow. Please follow. So we come here to this symbol. You can continue to plot a single sheet. So we have our configuration of the other side. We have here CWG to PDF. People who are not with me, let's catch up. Here we will do window. Window is the easiest printing setup, because this one, for the window, we just come here and highlight the area. Let me come back. So we have finished to set this one, paper. Here what to plot. If you plot this layout, it will plot the layout as it is there. But sometimes, because of the scale issues, it brings some problems. You come here to the window. Window will give you a possibility of selecting the area that needs to be plotted. So if you come here to window, you select from this corner, up right, coming down here. So all these settings remains like this, and then you come here. If you do preview, it can show you what is going to be printed. You see, this is how your drawing will look like when you print it. See, for people who have already put all the information here, they will also come. So what I'm going to do, I'm going to make this line, please follow the screen. I'm going to make this line unplotted because we don't need to see these contours. Remember what I was explaining to you the other time. But for someone who will be confused, you can just keep it now, like this for now. But I'm going to make this line unplotted, so when I'm printing is not shown, because I don't need it. And I've seen someone who has made many drawings in one file. So if there are many together, then you have these contours. It doesn't look well. So it's better you have them without this contour. But I can still print even this one. I come here, I go to the printout. I can create a folder specifically for power. I can call it power printout. All the printout of power will be in one specific folder under printout. So I come here and name it power ground floor. It's coming, you see. What I was explaining to you about the printout, like to make this invisible. What I will do, I'll create a new layer and call it not plot, and make it. You see what I'm doing here? On this small printer, I'm deactivating it, so everything which will be under no plot will not be seen when I'm plotting. And come back to these two lines and make them under no plot. Let me try to see now if I'm able to plot. If I do preview, they are still visible. Yeah, so now if I want to print them, you see they will not be visible. You see, they have disappeared. They are there, but they can't be shown when I'm plotting because they are under a layer which should not be seen when I'm plotting. So I can print this one also and call it updated power ground floor. So do it for your file. What I was explaining, if you have finished all the settings, please follow. If you have finished all the settings here, you can just come here, duplicate this, please follow, copy this, create a new copy, create a copy, you get this one, you call it first floor, and the only thing that you'll change, you'll come just here, double click here and move to first floor, and like make now first floor appearing. Make first floor the one appearing. Come down here, change the title name, the drawing title, and print a new one. than doing the same settings. Just finish one and then duplicate, just change the title name, change the sheet name, and when you click here, you can just move to the next file, to the next view, and have it here. Let's say this is second floor. You can move second floor here, come and change the name here, plot it, and save it to the next file. Hope you guys have made your files. You have put your names in the group. I'm going to create a folder where you save your drawings.
Sorry, sir, I have one question.
Yes, please.
Where do you put the new file that you have created for saving this PDF file? I'm
putting them in printout.
The one that we created.
Yes.
Okay.
If you are doing Power, create a folder, call it printout Power or Power printout, and save it there. You will have for Fire, you will have for Light also. So I'm going to create folders on Drive for you guys, so you can be able to save your files there. But for now, just print them and save them on your computer. Extend.
Hello, Mr. Taka.
Yes, please. Yeah, I can see it is very good. Can you zoom out the title block down there? I want to see the details. Did you put the contours of the title block and the contours of the legend and the other file under an unplotted layer, so when you print it's not going to be visible?
Right now it's not visible, and I've already printed it.
How did you make it not visible? You put it in a white color.
That line that were here.
There is a line which is around the legend and around the drawing.
Yes, by using layers. As you have said, there is a layer which called no print, and I put it in a freeze. Right?
Okay. Can you now duplicate? I
forgot.
Guys, duplicate in your file in first floor, second floor. Then you just change the drawing, and you change also the title in the background. Sorry, in the title block. So then you can also plot ground floor. You can also plot first floor and second floor. You understand how to do it? Go there. There is where it's called copy and move. Right click. Yes, tick the one below. There is something below there to tick. Below. Yes. Yeah. Then click on OK. Yes. So give it a new name. Call it first floor Power. Then you go. This is very good. Call it first floor. Then when you finish, you will double click in the other drawing up there and move until you get first floor appearing. Yes, boss. The floor plan. Sorry? The floor plan. Yes. It's not that visible. So it should be a problem of the background, but this is fine. We can set it up. Print all your drawings. Print first floor, even if there is nothing there. I want to see names and a new background. Print first floor, print second floor. Yes, why not even light? We say in Swahili of our country, today is today. Leo ndo leo. Yes, bring bed.
Mr. Taka, I've already printed the first floor.
Yes, the one for first floor. Is it this one or this is still ground floor?
This is first floor.
Okay. Can you zoom it?
Sorry.
Zoom it. I want to see the drawing. Or it's fine. If you are confident that this is first floor, change all the information in the title block, make it first floor. Then also print it. Do also same with for second floor. Now I only have 8 persons. Are we only 8 people? Maybe. Professor. The PhD holder in AutoCAD. You have first to submit your drawings here. Are they going to drink it if we are not coming? You have to wait for us. Gabriel, I've shared a file, a link in the WhatsApp group where you can save your work. Everyone has his name there. Please drop there your work. You put power, drawings, light, and fire alarm. We're resuming the training in 15 minutes. It is also the time for people in the office to take their breakfast, so as it is not becoming a lunch now.
Those are the drawings of power, of lighting. Should be drawing or just a title block.
So for people online, we are resuming in the next 5 minutes.
Okay.
I need to see your files in the drive. Gabriel, did you save your files in the location I've provided?
Yes, I have saved the power circuits drawings only for those 3 floors.
Okay. Sorry? You're going there. DB, everything. Okay. We even add some mounting height details. Even our light does not have yet the control. After pictures. How is it? The mountain is down.
Tataka inserting the title block.
Steady?
I'm saying inserting the title block to the model is something that is very strange.
Yeah, that's why it's better you do it before, and all the files will be taken from that one. Normally we should have done it in the template, so when we save as with the same setting. Now you need to do it in light and fire alarm, but next time you start everything, all the parameters. Just when you finish to attach the X-ref, you also set the title block and everything before you start duplicating them in subsystem folders or files.
Okay.
Yeah, it will come with time.
Because even right now, I'm unable even to insert it, even though the last time I did it.
It should be hidden somewhere. Just a matter of scaling. Hope everyone has saved these files. Guys, I have to resume the work. I have a lot to cover today. Who is Musa? I did not tell people to send a printout. You have to follow instructions. I told you to send power. I did not tell you to send printout. Hmm? And why do you have so many files? Hmm? Why do I have two ground floor? Just keep the latest. Said. Who is Said? I said create power. What is power draw? What is the power folder? Hmm? Almas? Who's Almas? Ali. Who is Ali? This guy also has put his name here. See, his folder is empty. He's following the training on WhatsApp. Bryson. The file is empty. Yeah, your folder is empty. Yes. I don't know. Can you save one video somewhere? Remove it in your drive so you can be able to share your file. Emmanuel. Gabriel. Who is Gabriel? The other guy. James. James? Who is James? Where is second floor? Hmm? Sorry? Today I will stay here with you. Omar. Okay, so guys, let's proceed. Finance people are now able to print. Because you can't pretend doing design if you don't know how to print. So what I was saying for people online, hope they can hear me.
Yes.
Gabriel, normally next time, huh? Boss. I was saying normally next time when you are setting the new project, better you finish all of this before you even start designing. It's better because at any time, any stage of the project, they can tell you print out and send us your progress. It's not now when you start looking for a title block. So the better you set everything, then you start working. So at any point, if someone tells you, send me your progress, you can just print out and send to him, than spending more other 30 or 1 hour struggling with the title block. So it's better you have all these process before you start any design work.
Okay.
We're going to talk about circuit breakers and protective devices in the next few minutes. So I think this is a general knowledge, and I think the big part of the engineering I'm not teaching you anything new because you guys are experienced and master the local context on where the design side of things is done. So for the next hours of this training, we'll be sharing insight on the best way to do this, learning from each other experience. So I'll just be here like a facilitator to let you. Yes, boss. Yes, boss. Let me. Yeah, you said that how do you create a title block? Okay, a title block can be created as a file. The way we are doing what we are doing now is the same way you can create a title block. So let me open it first.
Mr. Taka, please share your screen.
Okay, let me do it. So I was explaining, these are just lines, as you can see. They are just lines, notes. You can add yours and delete, change things and whatever. Yeah, so the way you are seeing this title block made with lines and rectangles, the way you can also create yours if you want. But what you have just to make sure you follow is the, how can I say it? You see, paper format. Paper have different format, and the ratio between this length and this is always uniform. You know, it's like A4. The ratio between this and this is always uniform. So when you make your title block, you have to consider that. Even if I can scale this up and down to make it fitting with from A4 to A0, but this size here, the ratio of this size to this size should be following the size of the papers, so we can be able to. Yeah. Yes. No, it will do. They have the same ratio. You can try it. This guy is. Gabriel, we are checking something here regarding measurement. We will update you. So we have A4. Sorry? No. I took it from somewhere. There are even resources online like blogs, title blogs, even floor plan. They're online. Yes, a lot of stuff. If you come here, for example, and you go for, you say title block. There is no title block by default in AutoCAD, and if you get one, is not a good one. It's a mess. Title block, CAD, GWG, free. See, get many. What is a title block online? And you see there are some which are vertical, some are horizontal. It's up to you. You can also do yours by default. But as I was explaining to you, in big companies, there are people who are in charge of the they're in charge of the drawing setup. Like they're the ones doing templates, title blocks, even setting layers. Like these few items I'm telling you, put power red, put light green. For them now they have a lot of things. They have architectural things, they have civil, so they have a full template of how each line should be. Like all the doors should have this color, all the windows should have this color, all the roof should be in this way. These are how parameters are, because that helps to communicate between different disciplines. Otherwise, if these guys are using meter, these are in centimeter, these are in millimeter, when you give him your drawing, it becomes small. When you go there, it becomes big. Which was written in the title block is becoming bigger than the title block, so it's become a mess. Yeah. So I was saying that we are going to go through this for the next few minutes, trying to go together through this and understand the main component for power protection or circuit protection or protecting devices. So these circuit breakers and other protective devices are very important components in electrical systems to ensure the safety and proper functioning of the electrical equipment. So proper classification and sizing of these devices are critical to protect the electrical system from overcurrent, short current, and other potential fault. You said your name is? Your name is what? Davis. Okay. Do you know any protective device used in electrical systems? Sorry? You know? Tell me some. Circuit breaker. Yes. 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 You don't know other more? Is the isolator a protective device? Is the isolator a protective device? NCCB? And what? Yes. NCCB is for what? You can't go deep like that.
Yeah.
But you're going to design it and choose. You choose according to the type, and that's why you are here. Okay. Can you list out some protective devices, you know? Yes, like in terms of protecting circuit or electrical installations. We have what and what? Sorry? Yes. Circuit breaker is also a family. There are many types of circuit breakers. Okay. So we are going to go through a classification and check, because the sizing of it is very important, as I was explaining to you the other time regarding the voltage drop and the circuit, the short circuit current capacity of the equipment. Sorry? Yeah, you'll get more from seniors here. Don't worry. Yes. So we are going to go deep directly into the classification of them and the operation context. So we have a first one. We are starting with protecting devices. We have the residual current device, RCD. This is mostly for general use. So an RCD, it is a life-saving device which is designed to prevent people from getting fatal electric shock if they touch something live, such as a bar wire or maybe a metallic part of a machine which is in contact with the live part, the live contact of the wires. So this helps people to be protected. So how it works, normally it used to sense the difference between the current entering and the current going out, because normally they should have the same value. So if the current which is passing through the RCD, let's say from the red point coming inside, is different from the current which is going out from through the neutral, that means there are some residual currents that are passing through another channel, and it depends on the setting. After some values, it has to trip. So that value is called the sensitivity of the RCD. Some are 10 milliamps, some are 30 milliamps and beyond. It depends on the sensitivity that people want to do. So if maybe you are working in a let's say a wet area where it's very easy for a person to get contact with live contact of machines, or it's very easy for someone to have a very low resistance of his body, then you have to increase the sensitivity. Or maybe you are operating in an area where installations or people who are working in that area are not that knowledgeable a bit. We are working in installations where we are expecting people with different context and culture. Let's say you are installing an hospital or places where people have to be, where the safeties are very required. It could be also depends on the type of machines that are being used, and that will not resist on any leakage of current. But mostly this is the technology. In RCD, as you can see, it has 2 poles, which is not common for other type of protections. And having 2 poles, that does not mean that it is working in different current settings, or let's say 2 phases or 3 phases. It's still a single phase equipment, but for it to sense a leakage problem, it has to check both the phase and the neutral. So you can see on this picture, don't know if it is clear, they are showing the sensitivity of it. You can see it is 30 milliamps. Some equipment will be having 10 milliamps for the most sensitive equipment, and some were having a value beyond. And I've explained to you the context of the choice of such equipment. So this is the way you are installing it. So you have to connect the phase through the main the right side, going down to the load, and from the load coming down to the neutral, going back, and here we have the earthing part. So here they say an RCD does not work itself. Can someone try to explain us why, for a full protection, the RCD need to work with a breaker? Does someone have an idea of why? To ensure a full protection of this circuit of the people operating here, an RCD should always operate together with a breaker. Do you have an idea? Boss, can you tell us why do you think an RCD needs to work with a breaker to provide a full protection of a certain circuit? Do you have any idea? Now, I'm saying full protection. Full protection means overcurrent, overcurrent, short circuit, and also the leakage. Because you will not protect a circuit only against the leakage. Yes. 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 So a response to that question, as I'm saying, this device, it only provides protection against leakage. In case there is over current, let's say the machine is running above its capacity, or maybe this circuit was supposed to be 16 amps, and for any reason it's now 20 or 25, this device cannot act. Okay, it's only acting in the case of a leakage. So if there is a short circuit in this installation, this RCD will not trip because it doesn't have that capacity. So that's why if you're using an RCD, it's always good to add, follow the screen, it's always good to add another breaker. We'll see the other type of breakers that can work together with an RCD to now provide a full set of protection. So the RCD will protect against the leakage, and then this breaker will protect against what and what? Sorry? Overcurrent? What else? Yes. So this breaker will now protect against overcurrent and short circuit. Do you know the difference between overcurrent and short circuit? Sorry? You are doing what? Hey, fikiria tuambie. Boss. Your name is? Yes. Can you tell us the difference between overcurrent and short circuit? Overcurrent, short circuit. What is the difference? Don't open it, or don't open Google. Hey, someone is responding. And then in short circuit, someone to support? Boss. Hey, okay. And overcurrent? Okay. So is a short circuit an overcurrent? Short circuit is also an overcurrent. Why? Sorry? Is that overcurrent? So short circuit is not an overcurrent. Huh? Yes. Yes. So short circuit is not an overcurrent, or it is, and is like the normal overcurrent a short circuit? It's not. So both are overcurrent, but normally the word overcurrent is when the value is still in a controllable ranges. Let's say, for example, you are supplying a motor, and for a reason the mechanical part is stopped. You know, the motor should work, and yes, when you block the mechanism when it's still supplied, it will call more power to try to keep moving on, and that time it will call a lot of current. Let's say if it is operating in 20 amps, it might go to 25 and 30. So that is one example. Another one, let's say a motor, because you know it is producing mechanical force. You are connecting it to a bigger machine than its capacity. So trying to move that machine, it will try to call more current than what is rated to do, because the more current is called, it can have more power to run the machine. So another simple context could be you are sizing a circuit, and the maximum current is 16 amps. Let's say if you guys have been studying at the hostel, they are sizing that this circuit will supply these 5 hostels, and people are expecting to plug machines. And let's say all of you guys are having your ironing at the same time. When you take 2 kilowatt times the number, or maybe you guys are cooking using a cooker at the same time, and while the designer of that system says students will be plugging computers and telephones, but you guys are cooking on a small circuit, that circuit will be overloaded. It is an overcurrent. So what we were explaining there, that both situations an RCD cannot detect. It only detects a residual current issue, as he was saying about earthing and other stuff. And protective devices, from their nominal value, they are always able to let an overcurrent which is going for a short time to go through. Let's say if you are making it 1.2 or 1.3 above its capacity. Let's say it is rated of 20, but it's having 24 amps passing through 1 minute. You can still take it, but when it goes for a long time, then it has to trip. But for short circuit, it's just like a direct situation. So short circuit is as people were saying, a bypass, because we all know from the law of Ohm that we talked yesterday, current So to solve this issue, there is another equipment that has been brought. I hope people online can hear me. Sorry? So RCD detects. You see where do we have, let's consider that down here, where they're writing L1 and N. This is where you go to the load. If for example, this is a fridge, and the phase contact of the fridge is touching the board, and I'm touching it, normally one part of the current will pass through me, going down. So it means, as normally a circuit should be a closed circuit should be closed, like the same current entering should be the one going out. So when the device will detect that there is a unit of balance between what I've received and what is going out, it will say there is where this current is going. It means there is a leakage. Without knowing, maybe it is a person or it is a cat or something else, it has to strip to protect people against that. Normally when you are supplying by the standard, for example in Rwanda, all the power circuits are advised to be under a leakage protection, because it could be a cooker, it could be a fridge, it could be a kid playing with a nail in the socket and plug it there, so it has to strip in that time. Yes, so when it detects that there is a difference between what is going through the red and what is going out through the blue, it should strip. Yeah, because you have experienced sometime you touch like maybe a cooker and you hear there is something. Yeah, yes, so the higher that shock is, can kill even a person.
Why something now? Why something and why a triad supply?
It's small, maybe because the contact between the phase and that like between the phase, the live contact with the shape is not that obvious. Yes, when maybe it is a small one, then you just feel it small. But if maybe by mistake the earth which is connected to the ground is connected to the earth to the phase, or maybe they have done the connections of the supply wrongly, my friend, you can go in a second. Yeah, so it depends on how big is the malfunctionality of the contact. The critical is the contact, the higher will be the current leakage. So I was saying, to solve this issue of having a need of two equipment, they have introduced an equipment called an RCBO. So an RCBO has both protection against the leakage and protection against overcurrent and short circuit. So it's having the capacity in itself to fight against the both situations. So this is called an RCBO. It has the same logic as you can see here. You still have two contacts, like you come inter phase going down, go back neutral going outside. So it has the two characteristics, both for current leakage and for short circuits. And you can see here you have the leakage current written here. So I want to ask you a question. What do you think could be an advantage of using this compared to using a combined system? Or what could be what could be the advantage of using this, and what could be the advantage of using this? Why do we need to have them combined, or why people might choose to have them separate? Hey boss, why people want designer? Because this is design. Design means design, you know, like you are painting. There are some rules to follow just to achieve something, but people can go for different strategies. The aim is just to achieve what is expected. Achieve protection. Someone will choose breaker and RCD because I've never read anywhere that RCD are not in the market. So it's not like they have been removed because people are no longer using them. If you want to order a breaker and RCD to be like this, it's fine. If you want to use the RCBO which has the breaker and the RCB in one element, then it's fine. But I want to know from your view, what could be the advantage of using this, and what could be the advantage of using this?
I would say that the combination of two.
Yes. Yes.
Now the question is to ask why you see this over more.
No, I'm saying, what could be the interest of using this combined or using these two? Yes. Obviously, this compared to using only this, then this is giving more functionalities, but using this compared to using this too. No, say what you're confident with. Well, what you think, but there you are assuming Garama, but how are you sure that which one is cheap? You don't know. You say what you are confident about. What do you think? What could be the advantage of using this? Okay, this will be higher price. Maybe, I'm not sure even. Someone else? Technical side? Why are you busy with economic? We are not doing logistic here.
Like how it look like.
Mr. Taka?
Yes.
I think
someone is responding online. Tell us.
Yeah, I think using RCBO.
Yes.
It is more expensive than using RCD.
Yeah, but we are saying you using RC. Okay. You say RCBO is expensive than using the RCB with the breaker?
Yes.
Okay. So apart from the economic context, do you have a technical idea?
Yes, using RCBO.
Yes.
You can protect different circuits.
How we can protect different circuits with RCBO?
Like when someone even touch if it's a fridge, the holes and using RCBO. So if you using RCBO, it means that you're using that's line. If maybe it's a 3-socket or 4-socket. So those sockets will be cut if using RCBO because they will be connected in RCBO, and the other circuits will be normal controlling.
Okay. So me here I'm seeing a possibility of knowing the type of fault, because if you have overcurrent issue, only this one will trip. Then if you come back and you find the breaker is the one who tripped, you know like this system had a current issue. While if you come here and see this is the one which tripped, you know like you had leakage issue, which is not the case here, because here either it is leakage or it is overcurrent, it will trip and you will not know. And you know, even when you are assisting a system, it's easy when you know the issue that they are calling you for. So if you find it was a leakage issue, you can say, okay, let me go and check all the grounding system of the machine to see if there is something which is having a contact with the earth, or which is having a leakage between the shapes of the machines with the drive cable. And if they're calling you because it was overcurrent or it was an issue of a short circuit, then you will know. Let me check maybe if there is a short circuit in this installation, or let me check if there are some machines that are working above their capacity, or their issue of sizing. Because when you also undersize a protection, it will bring that issues of protection or of current. So it gives you a way to easy get the problem of the installation. So let's also discuss about the efficiency. Do you think this is most efficient than this one? If you have two equipment in series, like helping each other to achieve a global target, and the case where we have one equipment doing both, which one do you think is most efficient? Why? Sorry? Loss of what? Load gani? Yes.
One job of a current thread or a leakage. So if one device is monitoring both of them, you find this one more controls
Which one is most efficient? Yeah, mali tuna mbili wala tuna moja? Efficiency, like efficiency of the system, the reliability. Because if you buy Chinese breaker and you buy B, you see they're different brand, different price. This is most efficient. But I'm not saying about brand. I'm saying about you have two equipment achieving in together a purpose, and another one where they're combined. It's like you have monitor and screen together for a computer. Someone else is having a laptop, but it's not the same context. But I'm just explaining. Than connecting them to now make a computer, mwingine na laptop yenye na screen na keyboard pamoja. Yeah, just an example. Which one do you think is most efficient? Kwenye ziko mbili hivi. Jua nini? Hapana, mfano wa kawaida. We are electrical. Sorry? Yes. Yes. Yes, and someone else is both. Yes. So you find the efficiency of electrical depends on one other than one. Okay. I said for this part, I will appreciate you if we discuss. Yeah, I think everyone is having his view. I will let comment on your idea. So everyone will respond at his own. But here I'm seeing also the issues of wiring and space, because here it will require a lot of space. If maybe we have 50 circuits and all of them has to be like this, you see the system will be big and overloaded compared to where we have a single equipment doing both jobs. Even connection wise it will be easy because you have entry, exit. Yes. No, I'm not linking it to efficiency. I'm linking to the space. Yes. 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 I will not say it in that way. That's why I was not responding to the economic side. The economical context could orient for that. You have to see. First, technically, we are seeing both can work. Maybe better having them separate for someone who maybe has a lot of space. There are many contexts that make people choose going for one system or another. Let's say if you are operating, let's say the example of where we are working is a hotel, and the dB in the room is very small. So the more points you put them, it becomes big and it's tricky. In that case, obviously people has to go for another CBO because it is one equipment and it is reducing the area to be used. So some people who are sensitive on diagnostic, because they want to assess and to know the issues in the system, they might go for having them different. Then you also have to choose to go for the price and compare. So maybe we can do that assignment after to check from the same manufacturer, if we have a breaker and RCB and compare to another CBO of the same size, where is the advantage in terms of price? Then consider maintenance issues and all the other aspects, then can take you to decide. But both, I think they can perform and respond to the issue, because they're covering all the issues inside. So we have an MCB. Everyone knows this one. MCB. Can you explain us how it works? Yes. Okay. Yeah, so say it's protecting against abnormal condition of the network, means an overload condition as well as the faulty condition. So the MCB is used into low voltage network instead of the fuse, because here they're saying the fuse may not sense it, but miniature circuit breaker does it on a more reliable way. MCB is much more sensitive to overcurrent than a fuse. MCB is yeah, that is what they're explaining. So this is now what people are calling breaker by default. Like the breaker people are saying is this one. In my country, people are even calling it by a type. These people who did not go to school, they call it by a specific brand. Say, I want Teco. While Teco is just a specific brand of a breaker. It's not that the breaker. So they are saying that it is most used into low voltage. Low voltage, we know it is below 1000 volts. Is more sensitive than the fuse in terms of overcurrent. So we'll reach the fuse context, because the fuse also will help to protect against overcurrent and short circuit, but this is more reliable. It can sense overcurrent more better than the fuse. That the explanation they are giving. So application in low voltage compared to the fuse to protect against overcurrent, the MCB is the best choice. So this is the way you connect it. Very simple. Entry, exit. Can someone tell me the meaning of this? This small symbol here. What does this mean? These two, small rectangular and this half cycle. What does it mean? It should have a meaning. Both. What does it mean? Don't know. You? Sorry? Coil and? No, I'm saying this. This small rectangular and this small cycle, half cycle. What does it mean? Because a symbol has a meaning. Both? You know? Gabriel, do you know the meaning of this small cycle and the half cycle and the square or rectangular?
No, I don't know.
Yeah, because normally a breaker intervenes. This is for temperature related issues, because like you see, when you have overcurrent, mostly it brings more temperatures in the system. It means a breaker senses a rise of temperature, and it is having some sensors inside that can sense that the temperature is very high, and it will act. Because how does it know that there is a problem with overcurrent? So you say if this specific piece of metal is crossed by 2 amps, the size of it and all the way it has been made, it can take that current to go through. But when you go for 3, 4, 5, it will start hitting, and when it hits, there is a way it will change the position and trip. That's how it works. While when you are going for short circuits are mostly expressed into electromagnetic issues. Like there is a way even the frequency will change in the system, and that has a part of the sensor which can a part of sensor that can sense that change into the fluctuation of the power of the current, then it will trip. So it means when you see it like this, it means it can work both for thermic issues and electromagnetic issues to operate properly. Yeah. So we now have an MCCB. The MCCB is type of protection devices that is used to protect the electrical circuit from excessive current, which can cause overload or short circuit. So this is still a kind of MCB, but there are some differentiations into the application. You would see it here. They're talking about, you see, it's using a temperature sensitive device, a thermal element, with a current sensitive electromagnetic device, as I have explained before, to provide a trip mechanism to protect the isolation purpose. This enables the MCCB to provide overload protection, electrical fault protection against short circuit current, and electrical switch for disconnection. So this has also a disconnection part of it, and what I'm sure with, MCCBs are also used into above the low voltage. MCCBs can be used for higher or medium voltage. So that is one of the characteristic of it. So we have seen that MCB are used mostly for low voltage. We are having these domestic applications and residential, commercial for the general use. But when we go for higher protection, we are going to protect maybe income of transformers. We are protecting big loads that are supplied by medium voltage or higher voltage. Protection is going for MCCBs. So it means the protection against overcurrent and short circuit in the medium and high voltage is performed by MCCBs, because they have more functionalities and way of doing some settings of parameters. So this is the way it is connected. As you can see, we have also different parameters that it can control and the characteristics. So it has a rated frame current. It has a rated current. This is the value determines when the MCCB trips due to overload protection. So it has a nominal current to operate in, for which going above it can trip. So it has a rated frame current. This is the maximum current that the MCCB is rated to handle. This rated frame current defines the upper limit of adjustable trip current range, because the special characteristic of the MCCB is that you can also set its sensitivity. You can say make it more sensitive, less sensitive compared to where you are using it. Let's say if it is used to upper of or the income of supplying a motor, and you know when you start up the motor, there are some fall of current at the starting, which is not obviously a bad thing, because that is how the motor operates. If you put a normal protection there, then it will trip directly, because it will not know that this is temporary. But when you have an MCCB, there is a way of setting that for this period of time, let's say 10 to 20 seconds, you can handle this range of current, and after that now you can trip. So it can have that functionality. So is when supplying those kind of loads, you can know that this is just like a situation that will pass, and I will go back to the normal operation conditions. So it has also a mechanical life. This is the maximum number of times that the MCCB can operate manually before it fails. You know, each device has a lifespan in terms of operations. If you put kids on switching off and on light every time, after some time the switch will fail. While it's still good, but the manufacturer, the way he has made the switch is like after certain switch on and off, the internal component starts to fail. So the more they are tripping, the sooner the MCCB will fail. The same with the breakers. All the protection equipment that are on and off, they have an operation lifespan that has to be followed. So it also has a electrical life. That is the maximum number of times that the MCCB can fail, can trip before it fails. So this is in terms of the choice of the equipment. There are some parameters to consider. You have to consider the working voltage. As I told you, it is operating between different ranges of voltage. There are some where you see it is above even 1 kilovolt, some are even beyond that. So you choose the MCCB not only in terms of the current capacity, but also the range of the voltage that it will operate in. So there's a trip value, which is adjustable. There's the breaking capacity of the MCCB, which must be higher than the theoretical possible fault current. But this is also one of the big factor to consider in terms of voltage. So am I buying an MCCB for low voltage? Is it for medium voltage? Or I'm buying an MCCB for higher voltage operation? So we have our friend fuse. I don't know if it's still a lot used here. The case of Rwanda, I've seen very few areas where they're still using the fuse. But can you tell us from your experience, where do we still need to use a fuse for protecting against the short circuit or overcurrent? Do you know a specific application where we need to use the fuse for doing protection? Yes? They put? Yes. Yeah, why do we need to keep using the fuse? Because you know one of the consequences of it, or the disadvantage is that you can't replace it. When it fails, buy another one. Yeah? It's like you shoot, it die. Eh? You can't go to the hospital. Can't wake up. Eh? You know those animals that when they give birth, they die. Eh? So when the fuse protect you, don't come to greet it anymore. You find it fail. You have to bring a spare. Sorry? It's cheap? Okay. So you think that there are some applications where it makes sense to keep using a fuse? Where are you protecting a building? Protecting? Okay. Okay. Why don't you replace it with a breaker? Are you not getting issues of them being replaced every time? Okay. Yeah, so mostly for unstable installations, it's not advisable to use a fuse because it can cost you a lot. Even if you're saying it's cheap, let's say if it has to trip once a week, then it is tricky. And you know it is not a device which is available anywhere, anytime. So let's say if your breaker fails, you might maybe not get the same brand, but at least you can go to a shop and get a breaker to replace it. In the meantime, you're ordering from your supplier. But it's not obvious to go in any shop and say, I want a fuse of 20 amps. It's not that easy to get it. So me, I'm seeing the advantage of using the fuse, because you can get it from in any size. It means protecting small multimeters or small equipment. It will be very difficult to have a small breaker of maybe, let's say, 2 centimeters inside the machine. But for a fuse, it's very simple. Just plug it somewhere there and then it works. For bigger applications, there might be reasons that keep people using it, but it should be. Yes, Gabriel, do you have an idea? Gabriel?
No. Yes.
Were you saying something?
No, 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 no.
Ah, okay. So the application is here used for electrical circuit to protect against overcurrent conditions and provide a sacrificial element that melts when exceeding current flows. It's commonly employed into residential, commercial, industrial, electrical systems. So we have a view of the fuse. So the wiring and fixing strategy, you have to connect into series with the circuit, and the design to melt when the current exceeds the rated value. So you have to choose the correct fuse rating based on the circuit current carrying capacity and requirement. You have also to install the fuse following the manufacturer guidelines and local electrical codes. So we have a switch disconnector. This is primarily used for the purpose of switch. It is to isolate electrical circuit equipment and machinery from their power supply for maintenance or servicing purpose. So it's used in the industrial, commercial, and residential. Is someone having an idea to add on this device? Disconnectors. Someone has a contribution there. Why do we need them? Why do we need to use disconnectors in the system? Hey guys, why do we need to use disconnectors? Sorry? So we can't use a breaker? You have to prevent? Because I'm saying it is on and off. Why can't you use a breaker for that purpose? Why do you need a disconnect? Sorry?
Is that automatic disconnect?
No, it's manual. Yes. Not important? Yeah, so I was wondering, why can't you use a breaker to cut off and on? Why do you need to add an isolator?
Disconnector switch is that
Yeah, disconnector. No, disconnector, sorry, disconnector.
I think the purpose is manually if you need to isolate a certain
Part of the installation, yes. You can use it. Okay. So we have the way to connect it. It's very simple. On and off. And you still have to check the carrying capacity of it, because that's also very important. Yeah, so that's what we can say in general, but you have seen it helps us to isolate the system. Yes, boss. Yes, but it doesn't have a protection capacity. It's only on and off. It can't detect any overcurrent. Yes. Like you come for maintenance, off. You come for you remove, you finish, on. Sorry? Yes, it's like a switch, but in the protection line. It's not a switch for light, like on and off. It is a switch in the protection line. You can have main protection, then you have your disconnector, or you have your disconnector, then the protection, then you have other items below. Sorry? So this is how you connect it. Now we have another view of it. It is called isolation switches. This is mostly now something that has a possibility of saying, am I on, am I off? Because that one is above and down. There is another one which can now show you, am I on, am I off? Because there is a theory regarding making sure that you have cut off the electricity. Like inside the breaker, are you sure? Is it on or off? But most of the isolators, big ones, let's say for these medium systems, you can even open and see. You see, even when these systems that you are using into a transformer system and whatever, the breaker is always closed. It's maybe having some chemicals inside, or it has some items inside. So you are not sure. Did I switch on and off? Because you can switch off, but it's still having contact inside. But these isolators are made for now ensuring you that I'm off. Otherwise, you will switch off maybe the breaker and it didn't work. You go to operate and you get issues, because the breaker cannot have a possibility of it being opened by view like this. Why? Because the operation of it requires you to have some chemicals or some infrastructure. But after switching off the power using a breaker, now you can go for a isolator and switch off, and you are sure, by my eyes I've seen that I've cut off power, and I can go even for operation. That is what can be said as a contribution. Hivyo guys, kwa sababu breaker zile kubwa zinatumika na transformers, unaona ni breaker iko closed system. Unaweza ku switch off, lakini haujue, hauko sure kama umekata. Lakini uki switch off an isolator, unaona kwa macho yako kama nime switch off. Yes. What if is not the case? Inside inaweza kufail. Unaweza kuswitch off inside ina fail, wala kuna still contact. Ni kusema ingelikuwa better hata breaker nayo ikuwe vile, ukiswitch off inakuonesha, lakini haiwezi kutumika na iko open, kwa sababu ile mambo ya kudetect ma overcurrent na ingine inapaswa kuwa na the way it is made. There are chemicals or other stuff that should be inside to have that possibility of protecting against overcurrent. Ndio maana wanaiongezea isolate. Na unajua kama unaenda kutumika kwa high voltage, mtu ambaye alikata umeme ni anabaki hivi na funguo ya isolate, mtu mwingine asije akarudisha umeme. Yes. So this is how the connection of it is, and that should be the end. So, any questions? Yes. Change over switches, another. Change over switches, change over. It is either this or another one. Sorry? I'm saying change over switches is changing from one post to another. This is just like an operating device, just to cut off the phone. Change over switches, another topic. Yeah. Any question? Everything is clear. Okay. So before we go to lunch, normally we had to go for designing circuit, where we are still far behind into design. So we need to resume our design process. For people who are still doing power, let's push and see what we can do. But I wanted to have a comment on what we did. So let's do that like this. Should we start by the easiest one or the hardest one? Easiest? Kuna mtu ana shida kwa fire alarm? Any issue on fire alarm? Is there anyone having a question on fire alarm? I think what remains is just to locate the fire alarm panel. I've seen some people putting it here. I don't know why. While I know this is in the room. This is inside the room. I know why people are putting a fire alarm there. I should put it somewhere in this staircase or maybe here in this corridor. Yes, boss? Fire alarm are going to a fire alarm control panel. Hatujaitia. Yes, we are not yet doing it. We are first. That's why I'm saying should we start by the easiest one or the hardest one? Yeah, we are trying to locate where to put it. But you know when you're also installing a fire alarm panel, it should be accessible to everyone. Should be accessible to everyone. As a corridors ni ya huyu mtu, because if now the house is turning to an apartment, are you going to come down here and operate it? Because I think this garage can be shared by everyone, regardless of the level. So if we have a fire alarm panel here, it's better, so everyone can come down and check. So what we can provide is to have repeater panels in each floor, so everyone can switch off the sounding system, but the main panel can be in the garage. Unaonaje? Umerudi sasa? So I'm saying this fire alarm panel should be installed on an accessible area where everyone can come and check. And I'm saying we don't know yet how this house is configured, but what is sure, this could turn it into an apartment where while one resident is using ground floor, another resident is using first floor, another resident is using second floor. So an easiest way or an easiest place where everyone can access it here in the garage, because everyone will put his car here and take the staircase to go on his floor. So the area which is accessible to everyone in this building is this ground floor. So what is this ground floor? So what we can just do is to put a repeater panel. A repeater panel, I've told you, is just like set. When there is fire incident or there is an alarm, on the repeater panel you can be able to know where is the incident coming and you can switch off. It means, let's say, if there is a false alarm in the ground floor, the person on first floor can switch it off. Say it's not a good alarm. Maybe there is a kid who is playing and came to trigger the MCP. Then another person even on third floor can come and check. There's an initial ground floor. Go down and come in to inspect. It is a kid playing. Then go back to his house and switch off the alarm. But the fire alarm panel now, the main one, should be at an accessible area, because someone will not come from first floor and enter here in your house and come to switch off it here. Understand? Yes, that is how I'm seeing it. Unless if we could have a better view of the entire complex. Let's say there is a guard house somewhere, or there is maybe another small house outside where everyone can access, then we can use it. But for now, a better area where to place it is here in the garage. Yeah. Sorry? Yeah. So I'm going to place it here. I think Gabriel, you understand what you are doing. Gabriel?
Yes, sir. We are together.
Unasikia sababu gani tunaenda kutia fala mpano hapa kwa garage?
Yes.
Yes.
Ili kila mtu aweze kuifikia.
My friend, you should be opening this file. If you are just watching me, it's fine. Today we do not have a lot of time. Please use it properly. So ask your question. Sorry? A combination? Yeah, if it's too much, there is a certain quantity. Because when you test, when they are doing testing of the smoke detector, they put a ladder here, then they bring the smoke very close to it and see if it can detect. Yes. A smoke from a car should not strip a smoke detector unless it is closed area and it is produced in high quantity. Then it can be a problem. Installation. Yes, we do it. We'll do it after finishing the design. We can't do it here now. People are not finishing yet the design. When we finish to install the, can you hear? That question is very important. He's asking about the single line diagram. We do single line diagram when we finish to set up everything. We know how many circuits do we have in each flow, what is the size of the protection. Then we'll be able to do a single line diagram. Obviously, it's very important. Yeah, but we have to finish first the circuiting before we go for that step. If you have finished the design, then we can do single line diagram. How many circuits do you have? What is the capacity? What will be the main breaker? Because I was thinking that we have a main DB that is taking power from the source. Then we have sub DBs on each floor. So it's the issue on the person on first floor is not affecting the person who is in the ground floor. The issue of the person on the second floor is not affecting the person who is at the other floors. Have you finished this? Print it and send it to me. Don't close your hands, my friend. Don't close your hands. Yes, boss. They are putting it in the staircase, going up, going in upper floors. Yeah, definitely. If that is the accessible area for them, I'm saying design. You will not read anywhere that is saying fire alarm panel should be in the garage. No, it's up to you. But condition it should be accessible. You can't put it in the storage where it's closed. Let's say if you're in the room, you're in the building like your house, you put it in the corridor, you put it in a corner in the living room somewhere. You put it mostly in the corridor. You can't put it in your bedroom. What if it's closed? And it should be easily accessible. So that's the concept. The same with the DB. The DB should be in an area where it is not that shown, but also accessible at a height that maybe a kid will not be able to come and play around. So for people who are finished with fire alarm, they can print, do the same settings as the one we did before, and send it out. So I'm just giving you this insight because everyone will work in its own speed. There are people who are far behind. There are people who are very far and they're about to finish. So normally this should be another loop connected from here, because from the rules of fire alarm systems, you can go up to around 90 points in one loop. So you see here, this is a very small house. We are having less than 10 points in one floor, so we can have all the points in one loop. So what we can just put is to add the repeater panel. It depends on the need of having it. So we can have a fire alarm repeater panel. Sorry? The fire alarm, the repeater will be on second floor. Yes, somewhere. We can also have another one on third floor. Or maybe, no, it's not mandatory. The repeater panel is for you to be able to display the issues of the system. Like you might be able, as I've shown you yesterday, in the project I'm working in, the fire alarm panel is in the security room in the basement where you have the security guard. We have a repeater panel at the reception. We also have a repeater panel at the main gate. It means the person at the reception is able to see where the problems are. He cannot do any setting, but he can display and switch off the alarm only. That is what he can do. He can know, there is an issue at the swimming pool. There is an issue at a certain guard house. So for them to get information. So let's say if I was responding to your question, So let's say if you don't have a lot of money to spend on this, what you can do, for example, is maybe to have a repeater panel in the staircase from second to third floor. So that one can be used for people who are there. And so the person on first floor can use the fire alarm panel, because there is no need of having a fire alarm panel in the garage and have a repeater panel in the room. That will be spoiling money for nothing. I'm just giving you different scenarios so you understand the choice of the design, where it comes from. Yeah, they might be strictly separate apartments while everyone wants to have his control on the system. Then you have to provide to everyone a repeater panel. It might be one building, one family, but spread on different levels, and just to put only one in the basement or in the ground floor. Yeah, but I feel hard if maybe first floor and the ground floor is not used, and someone has to go from second floor coming down to work on the repeater panel or on the control panel. I think people online can hear me. So the design is a journey. So if you have done something yesterday and today you have another view, open, change, correct, print, it's never fine. Even when we are implementing a project, you can find an issue. We have put a socket here, you find on site there is a beam there, you can't cut it. You have to come back on your design and change everything. There is a new equipment that is added, or the requirement is changing. So it is a journey until the project is running. People can still be changing designs and adding items. So what you can also do here this can connect here, and you go through the staircase to go up. Sorry. So this can be the last point going up. So have this like this, and from here going up through the staircase. So from there you will take another loop. Don't forget to save your file. We have this turning around, then from the last point so please take understand the logic here. These two cables going up, normally only this one, let's say this one, if you want me to make it red, so normally it should be a loop, should be a loop. Let's say I'm making it blue for you to understand. So this blue one from the last point is the one which is now starting here to come to the fire alarm control panel, repeater panel, then continues here like this, turning up to this one. So let's say if this is the green one going up, so the second flow will take from this, and only the last point on second floor will come down directly to this one, because all these equipment are on one loop. Means this is the one ending the loop on first floor, going on second floor with this one, start here. When you turn, you continue, take this green one. This green one is the one which would start third floor, and from the third floor, so if you have this green one starting the equipment on third floor, so the grid point is the one starting the first point on third floor. Then from here, last point, if the last point is this one, now we'll come down to the basement, or sorry, to the ground floor. Let's say if this is black, for example, So the black will be this one. So the connection will be this. I think you understand the logic. Should be in one closed loop. This is now going down. So normally this is going to first flow. This is coming from second flow. We have the two here. We also have going to second flow. No, this is going to second floor. This is coming from first floor. We have coming from second floor, so coming from first floor. It's coming from ground floor. Yeah, so this is how the loop will be organized. Going to ground floor. Yeah, so this is how the loop will be organized. So after this one, we go on first floor, we turn around, then we go up to second floor. From second floor, we come down to ground floor, close the loop. And here you can do the same settings as we did for power, print, save, and send to. Any question?
Yes, guys.
No question? Yes, please. Yes. Yeah, but it shouldn't be the highest priority now, as that can take you a lot of time. You better focus on the design. Yes, because now you're jumping on power. I think if column is clear, no one has a question. Yes, boss. Yes, so the difference between those two, the fire alarm panel, guys, the fire alarm panel is the one which is monitoring the system in terms even of the loops, because a fire alarm panel has loops, like for big systems. As I said, depends on the manufacturer, but where I'm working, the big project, the fire alarm panel has the capacity of hosting for each loop 99 points. So we have a fire alarm panel, the first one, which has a capacity of 8 loops. Means in the way that those elements are configured, issues happening on first loop is different from the issue which is on the second loop. Even the last setting to do, like, because this is there are systems that are called addressable. It means the way the programming is done in the system, the fire alarm panel is able to know the issue is coming from room 10, because the smoke detector is given a name. Let's say this is a conference room, this is a reception, this is a restaurant. They will know if there is an issue here. They say smoke detector number 1 in conference room. It will detect. So the parameters, because let's say you're doing maintenance here. People are doing some painting, or you're doing some activities that can release dust to enter in the smoke detector. So it can trigger wrongly. So what you do with a fire alarm panel, you are able to switch off this. So let's say for these hours, this smoke detector is not operating. There is a way to enter in the system, because the fire alarm panel has a screen, has all the buttons. You can parameter and say, I'm removing this smoke detector in the system. But if a repeater panel can't do that, because the repeater panel, it only has a role of displaying and switching off the alarm. That is only the only role it can do. So you can have as much as repeater panels, depends on people who need to get information. Let's say you are in a big building, it has a management office. You are putting in the room of the manager a repeater panel. The security officer outside also need to know where there is an issue. You give them a repeater panel. Let's say the receptionist of the ground floor where the building starts, they also need a view. You put a repeater panel, but you can't have fire alarm panels everywhere unless they now become subsystems. Let's say first and second floor, it is a totally different system. You give it its fire alarm panel, it's totally different from people who are on second and third floor. When there will be an alarm in first floor, the person on third floor will not know, because they are different systems. That's how it operates. So it's always interesting to have the big system somewhere to control everything. Then you give repeater panels to different people, depend on the actions you need them to do. And something you can give to repeater panels different capacity or different purpose. There is a repeater panel you say only for display. Don't do any action. Let's say if it's the security guard who is not instructed, cannot maybe know how to switch off a fire alarm, you say you just get a possibility of checking a display, of knowing where is the issue, and letting other people who can switch on and off the system and things like that. But the person who now have access to the fire alarm panel should be someone who is instructed. Even when you install the system, there is a process of handover where they oblige the person who has installed the system to teach the operator of the system. So the person who will be working in the area where you have the fire alarm panel should go for a training to know how to operate that system. Because in case of the issue, you don't want to troubleshoot. Unless it's very critical, then you have to call the person who has installed it, or maybe another subcontractor who's in charge of maintenance.
So your perspective, you say that in a building, let's say the 10th floor or 5th floor,
yeah,
how many fire
alarm panel?
Yeah, fire alarm panel in that system installed. But yeah, I saw they have a lot of repeat. The panel to be a lot.
Yeah.
But we have one fire panel as the control of those repeater panels.
Yeah. So what you do, you might have one or two. Depends. But what I'm saying, all they should be located in one area, to the person who is in charge of controlling them. So the project where we are working on, yeah. So let's have a look on. Time is going very fast. Let's have a look on power. So I've received a very important. Let me go back online. Maybe they have questions there also. Mr. Gabriel, how are you?
I'm fine, sir.
Are you good?
Yes, I'm good.
I wish I could have you here.
Thank you. Thank you very much. We are together.
Please push.
Okay.
We'll send you a soft copy of the certificate. I'm just kidding. So, guys, I'm saying I've received a very important question from, what is your name? Sharif. Yeah, Sharif was asking yesterday, how are we putting DP switch together with other elements in same circuit? I think here the main concern is about the capacity. We have to check and confirm that the capacity of the machines that are running on the DP switch are not exceeding the protection capacity of the breaker, because in average circuit for power, they should not go beyond 20 amps unless it is a specific load. So that could be our targeted rating. I've gone through some research in the evening, and some standards are advising to have a DP switch on its own circuit. So I'm just opening a discussion around that. If someone has a different view or a comment on that, we can take a decision together and move on. Any comment? Yes. You say from? There is a? Yes. But in this case, they were separate for each different point. Any concern regarding that? Because this is not this is a separate, like this is a, how do you call it? A system which is not centralized is how? Because I think from centralized you mean like you have one big system which is now only having supply in different areas, like yeah. So I think here we are in the case of a system which is having each machine with its own DP switch, but we still have to check the capacity. No, it's saying in this existing system now we have DP switch together with other sockets. Like even here we have two non-sockets. If you combine this capacity together with the socket, you might go beyond the protection size, the nominal one. While we are targeting to keep our protection sizing like on a nominal value. So this, what I'm saying, is not good to say we have a breaker of 6 amps, another one is 10, another one is 15. It's like you are messing up. It's better you have a way of arranging your circuit so you have a common protection, unless there are loads that are consuming beyond, and you need to give them a specific protection. So that's why we're saying, I've read from standard and the research I did, some areas they advise to have the DP switch on its own circuit, so it's not interfering with other loads. So that's what I was saying. let's have a common conversation and get a decision for that moving on. Yeah. What do you think about that?
Just giving
Because it has implications. The more circuit you have, the bigger will be the dB, and also even the wiring. Because you have to take from the when you mean a circuit, means you have to take a cable from the dB to that point, a specific one. Sorry? Yes. Sorry? Yes. Yes, yes. Yes, yeah. That is what I was saying. Because like if you have put 2, then it means there are some DP which are average 15, 13. If you put them 2 together, you are already at 26 amps, while the protection is 20. So it should not exceed something like 17 or 18, because you should still have to have some gap between the nominal value and the existing consumption. So yeah, so if that is said and there is no any comment on that, I will advise that we put the DP switches each on its own circuit, so we are sure that we are safe and we are not going beyond the protection capacity of the breakers. Because for this project we'll have the average protection for small power at 20 amps. I think that is clear. Okay. So if that's the case, now this socket will be on this. So I will have 2 more circuits for these 2 DP switches. Yeah, each DP will be having its own circuit. I'm just checking this. This is now coming here. David, I want to ask you something. Can you check if those guys are ready? Yes. So I'm trying to group back the point. So now this is now one circuit. This is another circuit. And this is going here. This is there, and we can have these three points in one circuit. Yeah. So we now have 1, 2, 3, 4 plus the 4 DP switch with now 8 circuits. So that should be the same with the other areas. I think it should be easy. that should be easy. And let's check if Mr. Gabriel is with us. Gabriel, I think we are together. I will need some time to see your screen, but I hope you are together. Rama is not talking. I don't know why. Yeah, so this is the principles that these are the principles that we'll have during this. So what we can do is now to update the circuit naming. This is 1, this is 2, this is 3, this is now 4, this is now 4, this can be 5, 6, 7, and 8. So we delete this one. Have 1, 2, 3, 4, 5, 1, 2, 3. Yeah, 4. Hope everyone is working on this. I'm seeing some people just sitting and watching me. 5, 6, 7, and 8. So that should be the same way. We also have one here for this 3-phase socket. It will be 9 now. So the only 3-phase socket that we have will be 9. Save. So it should be the same with other flows, with the same logic, the same strategies. First arrange your points, then place the circuit, and yeah.
Where you can pick your water up here. I'm gonna leave it as none. I don't have a printer hook. Once you've got 8.5 by 11. Got layout selected dirt, a title block. You're going to use the insert command just like you would with any block. So you can type I and enter, or insert and enter, or spacebar for enter. That'll bring up the insert dialog box. And now you're going to browse to where you saved the downloaded templates. I've mine in templates folder, and we're going to use the 8.5 by 11 title block in landscape, which means it's wider than it is tall. Portrait would be this one, where it's taller than it is wide. They both come with the for free if you download them off my website, or titleblocks.com, where you can get the full template with 11 by 17 and 8.5 by 11. As well as scale bars and north arrows and all that. You can buy them there. I think they're $29 right now. It's a pretty good deal. It saves you a lot of time. But back to this. To insert a title block, you select it, hit open. We're going to specify the insertion point on screen. So you're going to leave that box checked, but you want to make sure the scale is not checked. We don't need to scale it because it should be coming in at 8.5 by 11. So we're going to hit OK. We're going to hit redefine if you happen to have something else in there. That's just because I was playing around with this earlier. So as you can see, the bottom left-hand corner is where I'm inserting. So I'm going to zoom in as tight as I can here. Keep zooming in. Oops, I lost it. Zoom out a bit. Zoom back in, and there's the left corner. So you're just going to want to line those two corners up. See how it looks like it's right on the line? And click. And you can zoom out and see how you've placed it. Now if you look, you can see this dashed line, which is the print border, has only the margin around it. It's completely outside of the title block. That means you've done this right. The inside of the dashed line is the printable area. So all of this title block stuff is visible. As you can see here, you can insert your own logo. To do that, you can click on the block, right click off my website, or title block for insert and enter, or spacebar for enter. That'll bring up the
Mr. Taka, if you are talking, please unmute.
Yes, I was asking people how far are they with lighting. How far are you with lighting?
Lighting, I'm not going any far.
Why?
The calculations are so tricky.
But they're not that tricky.
Calculation.
What is your question on calculations?
Reading the charts and you put them to the formula.
But I think the main issue here is to check the specific light, to get the specific light. Once you have the light specifications, then it's fine. Guys, what is the hard part of the lighting? Only choosing the light, right? Well, why is not done now? Sorry, I've given you everything now. You have the type of light. You have no. We're not talking control now. I want to see a floor plan with number of lights at the expected area. And I think you have the presentation. I did not give it to you. Sorry? I did not share. Did you ask it? I did not share. You have what? You have the 1 and 2 only. In the 3 there is no light. But did you ask? Did you ask for it? When? So that's what made you not working. You see, lighting is there. In the 2 there's lighting design. You say that you don't have it. Eh? Type of light. Type of light is. Don't you have this file? You don't have this one. No. What are you asking now? Sorry? Which one? Is this one? The big what? I know what he's saying, he's talking about. I even said yesterday in the group in the night, someone have a question, please put it here. People were sleeping. Hmm? Oh, maybe guys are living here. They stay in villages around Dar es Salaam. After the training, you are not online.
Yeah.
Guys, you have everything. You have everything. You have everything. Let me share with you the other light. But this should have been sufficient. This file should have been sufficient. What do you need? What do you need beyond this? Eh? You have the level of illumination. You have also the type of light. Now for this room, this area, go and check on internet linear light. Choose a specific one. Check the surface of this area. Calculate and know how many you need to put there. Which one? For this one, I will put one here and the second one here, and make sure the distance here between the wall and this one is the half of the distance between the two lights, as I explained yesterday. So we are taking a break for 45 minutes. I resuming at 3:40 minutes. I know how I will help you. We're going to go back here and choose the type of light, code, and also the number. Maybe that will help people. Otherwise, I'm afraid that we come here tomorrow and no one has done lighting system.
Sir.
We are going in break up to 3:40 minutes. See you there. So for people online, we are back. We are going to take the short presentation from one of the students here who has made some progress. Check on what we did so far. We are going to focus mostly on specific rooms that has different type of light, so we can give a view of how to proceed, mostly starting with ground floor. Then everyone will continue with other areas himself. Can you share a screen? Share screen. Share screen on Zoom. Hey, okay. Let me give it to you. Link sent. The link has been sent. Can share AutoCAD. can't hear me. Can you unmute?
Can you hear me? Okay. So we're going to start with the bedroom light, ground floor, master bedroom. So the first thing you do, you specify the area. So you can go for a rectangle and specify the area, say from here until here. And then you do a command line, properties, and highlight your room to check for the area. So the area here is 13.8 here. So you fill up the area. And then there's the value of E, the lux required for the room. We were given the file here. Where is that? Wait. Yeah, we are given the file here for the bedroom is 300. So we're going to follow that values. Okay, so now we're going to look for the light. For the lights, for the bedroom, usually we use downlight. Downlight. So here is the list for the downlights. We have various lights to choose from. So we may choose to select one of them. Maybe this one. Copy. Then paste. Then open the link to get the data sheet. Here, you download. And then you get the data sheet from here. So the most important thing we check is the lumen. Luminous flux is 2000 for this one. This is the most important thing. But when we include it, we have to name it in such a way that we can get back to it. So when we include it, we're gonna use this name in the title block. Okay, let's do it. So we go back to the AutoCAD. From the legend, we have downlight here. Okay. So we go block editor. And then we may choose to name this one, say, downlight 4, for instance. And then we save it, save block as. So the name we copied from here, so that it's easier to go back to the data sheet online at any time. So we copy that one and come back here to paste it. Maybe, for instance, we need the watts, we can include 22 watts. Say 22 watts. And then don't forget to tick this one, save block as definition. So, okay. And then this is the light. We can include more information, however you like it. You can save it, say master bedroom. Master bedroom downlight. And then save. This, you should save it from the symbols, from the file we had created before. So Nziza, AutoCAD Open, you go number 8, symbols. That's where you save it. So where is it?
Very important.
Yeah. Okay, save. And then you
For
close.
people online, hope you guys can, you're following what you are doing. And if you have any questions, stop us.
Yes, proceed, bro.
Okay, so you have to click discard changes because we use another block to create another block. So okay, and then now we come insert block after saving it. Oh, how do I push this? So how do I? Huh? No, I have to move it, I think. Yeah, okay. So we come here to the blocks and then we look for our light. And this one, master bedroom, downlight 4. So open it. So we scale it, you highlight it, you go to scale, and then you zoom in. Maybe you want it to be in the same size as this one. Say there, that's enough size. So take the light. So you want to come and plot it here. But we don't know how to plot how many lights. We haven't done the calculation. So how do I display calculation?
But is this different from
Yeah.
the other one? You have
Huh?
written it today?
Sorry?
Mapping is different from this one.
Yeah.
This one?
Yeah, it's different lights. So I have to calculate, and the area also is changing. And so let's go to the calculator.
Can't see anything.
Okay, I'm going to share it. How do I go back? Zoom.
Maybe you
Yeah.
share your close your WhatsApp.
Where do I share everything?
Go up. Screen.
This one. This is the top. Hey, this one.
Yes.
Okay. Okay. So calculator. Okay, so the formula, if you go back to the formula for finding the number of lights, so there's N equals to E, which is the lux required, the one we displayed here from the bedroom, and the area we have 13.8, so E times A. So you say 300 multiplied by 13.8, you get 4,140. So then we remain F, which is the flux we got from the lumen for the light intensity, and then we have the utilization factor, we take 0.8, and the maintenance factor we take 0.85. So we go back to the data sheet. Luminous flux is 2000, so we're going to use that one. Say 2000 multiplied by 0.8 multiplied by 0.85. So we get 1,360. What did I get down? Maybe not down. 1,360. 300 times 13.8. 4,140. So 4,140 divided by 1,360, you get 3 lights.
Yeah.
So you come back to the AutoCAD. Now we know how many lights we're supposed to plot.
Can we now just focus on the number of lights? Then we go for arrangement after. So not everyone can do that.
Just number of lights.
Yes.
Okay.
Just put the default there.
Okay. So we can say n here is equal to 3.
Of which type?
Downlight. And since we add the notation, we can even say downlight 4. That's how we named.
Then can you add the characteristics? The other link from the manufacturer.
Yes, sure. Say now F, we got 2,000.
No, not that one. The other code.
The code. Okay. Yes. This one.
Yeah.
Just move it there like that.
You make it fine. But the other line is long. Yeah, that way.
Okay. So say there's no kitchen in the ground floor, right? There is.
Can you share back the plan we had, or let me share it?
I think I know this one.
Yes. Then let me take it there.
Okay.
The mouse does not work.
It delays a little bit.
It's fine. So like L with what we just did there, I think everyone is able now to do to deal with downlight. They might be different capacity, but that is the procedure. So what we'll do, we try to see how we can focus on other areas that have different type of lights, mostly in big spaces. Let's say specify the garage with a linear light. Try the area where the hall next to the dining room for panel light. You can try the studio also for panel light. Then I think the areas are finished. If we do those 3, I think they can guide everyone on how to do it. We go step by step, and everyone understands. If you have a question, you can stop us. Then we have a common understanding. What do you think? Go for that?
For garage?
Yes.
Okay.
So check the size. Oh, it's fine. It's not from anywhere.
Okay. Let's specify one.
Can someone calculate that area for us? Can someone calculate that area? Sorry? The area. Of the area.
Look for the light and then. Yeah. Okay, area. Say properties.
No. You for. You focus on the light type.
Okay. Okay, yeah.
Are these are panel light?
Yeah.
We're checking the
yeah, that should be.
Yeah, the certain list that you check on the linear line. Up. Go up.
Okay.
I've seen somewhere. That one.
This one.
Can you zoom in? Go up. Above that. That is panel. Go down. Down. Go down. If they can have a straightforward linear line. Go down. Okay, let's try that one. What is the capacity?
So,
take the 35, 44, and 6. Can you take the code of the 34?
The first one.
Yes.
Okay. It doesn't select. I think it's a picture. It doesn't. Right. Copy link. Right. It doesn't highlight. I think it's.
Yeah.
Well, we can just take the name and try to BN 126C. Yeah, this one.
31.5.
Sorry? What?
31.5.
31 point?
For me.
Okay, so this is the light. This is the same one from here. Domain 4100. This one, yes.
Are you all getting what we are doing? So some people are not.
What's the area?
How much?
41,000.
41,000.
Sorry? No, we have just started lighting design.
What is it like here?
Can you explain it?
So we are looking for a number of lights. How many lights to put in a specific room? Yeah. So we started from the bedroom. So from the formula, do you remember the formula from yesterday? And can share within the formula. Come sit with this guy, maybe. Okay. Anyways, listen. So before we know how many lights to plot, we use the calculation. So there's a formula here. You can even use my book. And E lux required. Lux required. So use N is equal to E times area. So that's why area is important to look for the area first from the room. How much did you get for the corridor?
For the garage,
Yeah, garage.
I'm getting 1.1. So number of lights,
Area.
area 31.5.
Say 31.5. So area.
Okay. Or you can do copy first. You do copy of that the other side.
That?
Do the copy of the other side and then you just change the value.
Okay. This. Which one?
Copy that and bring it here.
Copy this one. Okay. Yes.
Not the contour. Just copy the name.
This one, right? Yes. So area is 31.5. Hello? Okay, so you finish area and then you take this E, which is the lux required. So if we go back here to this diagram, lux required for the garage, it's 100. So you just add here 100.
How do you add that formula inside the room?
Annotation. Annotation text. So the lux required for the garage is 100. So these are given. You see? Here. This is the E. This is like given. You don't need to look for it. You look for the area and this you have. And the other one, F. You get it here when you choose a light. Say we chose a light here, linear light. So you get it here, luminous flux, this one. Luminous flux. So this is the F, the value of F. And the upcoming values are utilization factor and maintenance factor. Utilization factor we take constant 0.8. So you can just write it here. Utilization factor 0.8 and maintenance factor we take 0.85. This value will remain constant for all of the rooms, these two. They remain constant. So after you have these informations, and then remain the F, right? Yes. Remain the F here. So F we got 4,100. 4,100. So after having this information, then you can calculate the N. N equals 2. So yeah, we are proceeding. So we go E, which is 100, times area, which is 31.5, right? 31.5. I get how much? 3,150. So if you go for the value of F, 4,100 times utilization factor, which is 0.8, times maintenance factor, 0.85. You get 2,788. So you take 3,150 divide by 2,788. Okay, so here we got one light. the flux is too high. So if you find yourself in this situation, okay, you change the type of light you choose. So here you change F, because the garage is too big, 31.5 meters area. It's not, yeah, square meter. It will not be sufficient for the uniformity. There's some spaces that will be dark. So yeah, we have to choose another here. Wait, where is the list? How do I? These all of them are too high. We have to. Yeah, we have to change a light with a lower flux.
So how much?
4,000. Try. Can't get panel light here. This. So, what do you think? So this website, you go online, you search for light. There are different brands. I select Philips because it's very commonly used in Tanzania, but you can select any kind of brand. So let's find something with a lower flux, maybe 1,000 lumen, like this. Yeah. Where do I download the data sheet? Yeah. Yeah.
I was saying the dialects ULD or photometric IES help you to have an input of this file.
So you can select this and try. Say maybe this one 2,000 lumen, right?
Like something, you know that?
Something?
Yeah, like 1.5, 1,500.
1,500. Okay.
No, you should get it.
From the list.
Yes.
Yes, this one. Yeah, this one.
Yeah.
1500.
Can you click the data sheet and see? Data sheet. Yes.
Where?
Data sheet.
This one. Yeah. Yes, this one. Yes. So you come, you look for
down. You go up.
Where is the lumen? It's not there.
It is there.
It is there. Where?
Yes, I've seen it.
There's a lumen per one. Okay. We can take it from there. How much is it? Can you do one?
This one.
That one. Yes.
Yes.
Okay.
This one. Which is 1500 from here. Yes. So we go to back to the calculation. So n is equal to E times A. E, which is 100, multiplied by the area, 31.5. Then the lumen now is 1500 multiplied by utilization factor multiplied by maintenance factor. So if we divide that one, we get 3 lights.
Yeah, very good.
So we just go back here and say.
But in the meantime, I'm preparing the next one. Can you explain to him very well how we are proceeding? So show him the values and the different parameters, other formula from the presentation.
Are you proceeding there?
So I'm saying let me prepare the next room. In the meantime, we are refreshing for people who are not able to understand how are we doing.
Okay.
Yeah. Ask your question. Hey.
From where?
Training all the parameters.
Parameters.
Like the parameters. No, don't take him for the type of light. Same the parameters. We are using
the formulas. Okay. If the lumens you get from the light, luminous flux you get from the light. Kwenye light. Online. Number of light. Lux required. Yes. Just look here. That's the formula. This one. N number of lights. E the lux required in a specific room. And then A is the area. A is the area. And then F, you get this from the light, type of light you choose. Flux also. Yes, but this one you get from the light you choose. Yes. Yeah. People online, is everything good?
Yes.
Yes, come on, yes. Get something.
Let's move on. The next area is 8.3. 8.3. The next one. The dining room is together with the hall.
Wait, dining hall.
And 8.6
area.
Sorry, 2.8. The next area. How much do you have? Because sorry, that area is a common one. Can you zoom out? Make it one common area.
Until where? For this hall and dining. Okay. Okay.
We'll take a panel light. Guys, clear? I can let you do the next room. Yes. You can explain. No?
Okay.
Yeah. Can you send the link of the website where you're taking the file?
Okay.
Seems interesting.
Yes. I think it was this one, yes.
Yeah, this one will be.
You get the specifications for the light. Yes.
You have to be a bit faster to talk about it.
Okay. 28. That's it. 26. 0.6.
All right.
I'm wonder why my area is different with those which you
with
get.
the boundaries. You combine the hall and dining room.
Yes.
Combine them.
Yes, I've combined it.
How much do you have?
47.5. Yes.
So maybe you are also adding the other
No, no
Yeah, I
wall.
get that.
Very sure.
You let me share the screen, please. Group chat.
Huh?
Share it.
Okay.
For the person online, this is the boundaries of this, go this way. Are you seeing my screen or?
I am seeing it.
This is the boundary. This one.
Yes, I've measured, sir. But what I think is the time when I inserting the drawing first thing, because even the master bedroom is different.
Area?
What?
Did you get 31 here? This area?
No, I didn't. All areas are different from my drawing.
You have an issue on the settings. So focus on the procedures. Don't care about the measurement too much.
Okay.
We're going to give you the value. Can you take back the control? You can share back the screen. Share back the screen. Are you taking the same information as the one he's putting there? Are you also writing it down? Because it will help you to design your own writing system. I'm trying to take some. Did you manage to get any light? No, for where we are, the power light. Still searching. You've got one? Which one? Fine. Yeah, it's very good. So 200, let's see. How many do you have? So 28. You do calculations and see. Sorry? I can't hear you. Is your mic on?
What about now? I was saying someone sent from the group the panel light for the hall, dining hall and dining room together as one room. We're going to use that panel light. Open that link and it will send you here.
Then you can proceed.
So it has 2000 lumens. That's the value of it. So if you have it and flux required for the dining is 100. So we take 100 multiplied by area 28.6. Then we take for the flux 2000 multiplied by utilization factor multiplied by maintenance factor.
How about yours?
We get 2 lights.
Okay. Is it enough there?
The hole is big.
They are not enough.
Yeah. I think they're not enough for you.
Okay. Let's go for this. Let me give you another light suggestion. Of 1,300. But they don't have that even fine. So try with 1,300.
Okay. That's the other light. Lumen 1,300. Yeah. And 8.6 and then 1,300.
Hello?
Yeah, the internet has gone off. It is reconnecting.
Okay.
Can you share your screen?
I got 3.2.
Sorry, internet was disconnected.
Wait a minute. So 3 lights.
I get 3 lights. Okay.
100 lux for dining small. How did we put
1,300.
I'm saying 100 lux.
The room is big, yes.
I'm saying 100 lux. 100 lux is small.
Maybe because it's the 2 kind of halls, so there's hall and dining room.
You change it.
Maybe each 100.
Yeah, normally we should have gone for the highest. Let's put 4 lights there, expecting to increase the lighting level. In the dining room, I have the need to is that require more light. Let's go for 4.
Because here in the diagram is the total is it will be 600 plus to them, combining hall and the dining.
Yeah, it's fine, but for 4 lights. No, it's not subjective. Put 9. Every time also when you are outside, it's better going for the higher value than like in terms of light, more than that. Let's get 3.4, 3.3. Better to go for 3 than coming back to 3 years. Let's go for 6.
Video here.
Is that the last room or
We have kitchen. Maybe we can do kitchen. The studio is kind of similar to.
Are you also putting the type of light that we are using? I'm not saying this you are putting the type of light. Like for it, people who need to
yes. This one pendant, right?
The way we did for the one, the last one. The way we did for the first one.
Or this one?
No.
The first one. Downlight.
The one we
this
did.
One.
Yes.
Downlight.
I'm saying there you see how we have put the code of the light.
Yes. Yes, the code. Okay. Yes, that's one.
Can you check? Okay. Please start it. It was different. Are we together?
This one. $500. So that's the type of light used here. Size for the studio. Studio is this one, eh? Kitchen. Okay. Kitchen pendant light. What's the size? It's coming 4.1.
Ilikuwa ya dining hall pamoja na ile dining room pamoja
for kitchen E500. 4.1. Oh, how much will be? Itakuwa nimepima vibaya basi. Ground floor. Ndio. I made some errors here for the kitchen. On the half, huh? Yes. Here. Here. Iko wapi?
Nataka kama mita 7 hivi senti mbili.
Yeah, from there, yes. Here, here. Mpaka hapa. Ndo hapa. Eight, yeah, around 8. There, type of light. I think from this there is type of light in the kitchen. What kind of light is in the kitchen? Pendant. Okay. And then okay. No lumen. Oh, haionyeshi. I'm still looking for pendant light. This one. Okay. Yeah. Luminosity. Hey. That's very high. Come on. Yeah, but the lumens, the flux very high. And the area is very small. It won't fit. Okay. Sichague tu moja, tuangalie. Traffic light. Like 900 easy.
You get measurements from someone else, and you know how many lights are here, and you know how to make them. That's the why you see now. Once you make this right, because if we are trying to get the measurements for the scene, you can see the straight line and arranging the fun line to tell you how to do it right. There could be a problem when we were downloading this one, when we were attaching the file. Just understand this formula. You have the level, the one that provided in the PDF. The PDF is what I need. Can you go back on the PDF? That one. You see everywhere the E. Those E's we have to find out what to put on the side. Depends on the area, have a level of light that is required there. Then you have I is the space. Then you have F. F is the line that the room. Then these are total. It's something that is very fast, very fast. The only challenge we have is to check to put the right light. We can give you a good arrangement. Because if you go for a very strong light, you can have one in the middle, then the uniformity of light is not good. But if you go for a very small light, if you have many in a room, then they will create a lot of installation requirements. You know, when you have many lights here, you have open the ceiling, you oblige you to do a lot of wiring. You have also to see with the eyes of the engineer. I'm in this room, it's the size it has. How many lights are accepted here? Then you for 5, 6, that's not the idea. Then when we are taking one measurement, we get 2 lights in 6 space. We reduce the capacity of light, now we get 4 and 6. Then that's why we are adjusting until we get the final setting. And I mean, the information we are going to
area
8.4. So focus on understanding what we are doing. light?
Yes, around 860 lumens.
This is
Yeah, but for the kitchen now.
suspended, but is this suitable for kitchen?
Well, the step is too basic. Maybe this one?
No.
No. Let me show you. And then here there isn't. That's true. Check lumens. Yes, but this it doesn't display lumens. It's difficult to get a reliable link. That's the other lumens, man. Shadow. Yeah. Nziza. Umepata? Lumens ngapi? Huh? Huh? Lumens ngapi? Too high. Room 8.4 meter square. Itakuja light moja kutoka calculation. Lumens inabidi chini. So for 8.4 it will be only one light. At least for kitchen 2 light. Right?
Hello?
Yes, the person who is leading us had a small issue with internet, but I think it's coming back. Did you get the light?
No, but I think this lux is too high for that kitchen. That's why we are still not getting it.
Yeah, but you know, kitchen should have a high level of light. If it's too dark, people will not know how to operate there.
But how about when the kitchen is, the area of the kitchen is not big?
Then when it's not big, it means they can accept at least 2 light inside. If it is small, we can put small number of lights. Let's push and see. We need to close this chapter. I have 850. This is big? Yes. Good. I have 850. Let me give you the link. Sorry? Yes. Yeah, okay, go. But make sure tomorrow when they make fast.
Mr. Lookman, your voice, please.
Oh God. So we're trying to look for a light that will fit in the kitchen here.
Okay, so you're taking that.
Yeah, the area is 8.4, so it's a bit tricky. Because we got 1 lumen, that's 850. But then it comes 7 luminaires, so it is too high, too much of a number. We have to increase the lumens to find a light, maybe 1000 lumens, maybe it can fit. If we do calculation, maybe we get 4 or 3 lights, something like that.
Okay.
You got 7?
You
got 7 lights?
Yes.
Did you get some?
Yeah, but they're not very decorative.
Wait, which one?
This one.
No.
Two ones only.
I was doing for the toilet downlight. I've already got one. Can I share?
They said it. Downlight, right?
Yeah.
Downlight ni polisi kubwa, wanatafuta pendant. And check online for pendant, yeah. Kind of light. Use for that.
Oh, you wanna use a different one other than ile 450?
1000.
1000? Okay, let's try that. But this comes 7 luminaires. It doesn't make sense.
Can you check?
1600.
Okay.
13.
Yes.
1600. it brings 13 points.
No.
13.
How?
Oh,
1,600, not 1,600.
What is the area?
area 8.4.
Ah, yeah, 3.8.
8.4. Yes, I know.
Oh,
3. Get three luminaires.
it is 3.8.
Yeah.
Yes.
Hmm?
3.9.
3.8. Yes.
Yeah, we can go for
Area is 8.4. Wait, let me open from the AutoCAD. Yes, this is the area. Area 8.4. Lux required 500 for the kitchen. This is the utilization factor and maintenance factor. So you take F equals to 1,600. Share the link for the like.
No, that is very tricky. Find that light
Ah, yes.
of that kitchen there.
I've got it all.
So here we get the number 3. Okay.
Can do. I try to focus on that area. Then finish. Then go.
It opens very big.
Sorry?
The way it opens, it doesn't.
Yeah, some more close. Go to see more.
Maybe I can copy from here or the code.
Does it have a code?
I'm trying to check. This one, right? Or she just copy the whole thing.
Maybe.
Yes.
You said that you did.
Yeah.
How many do you?
Just one.
How many like?
One.
Okay.
But I used the one which has like 1,000 lumen. So.
Well, 1,000.
Yeah, lumen.
In the toilet.
What? 10.6 watt.
Toilet is using downlight.
Yeah, downlight. 10.6 watt. But also I want to ask if the downlight, we already got it from the bedroom. So can we use that pendant downlight for the toilet?
What do you mean?
The downlight that we got for the bedroom. Can we use it for to the toilet? I don't know.
Come on, let's see how can come from. Yeah.
Maybe you can just take it and move it here. That's for the catalog. Moving here. That's for the catalog of the kitchen.
If you go back on the plan I had before.
We already got
Just The plan was to have no, we are currently back in the garage. I think we have come up the area.
Yeah.
The other thing is to do stuff. So we are going to control on the side of the switch in this area.
Yes.
So you plan to go to the garage for full manual.
Mm-hmm.
Let's see. This might be the person, like from the garage going to the room here. Could be passing from this area here.
From here.
No, here. Go up here. No, down here.
Down where?
Yeah.
Here.
Yes. That's how I'm saying it. Any other idea? That's how I'm thinking.
That's the passage here. But that's the passage for the maybe inside. But for the car, it's this door, right? The other one.
Yeah.
Front.
Yeah, I was talking about where to plug the switch.
Switch.
Yeah. No, we'll think about which switch we have. Can you see where switch is? One way. If we have one way, one gang switch. No, like where to put. Give me let me share the screen. Am I the one sharing the screen? Am I the one sharing the screen? What am I seeing behind there? Is it you? That chair.
It's yours, Mr. Taka.
Sorry?
It is yours screen.
Yeah, but I wanted to share now a screen. That's fine. Give me the cable. Give me the cable. Yes, I was saying, for me around this area here, the most suitable area for the switch. And people who are coming this way, they can enter here, switch on and off. And if they are leaving, going this way. So we put a one way, one gang switch there for switching the light in this area. Yeah. In the corridor, we have planned to have a movement sensor. Can take it even online. Can have a quick one. Can make something temporary. And it's MS movement sensor. Movement sensor. And add it here. kawaida. Is the tea ready? Is the tea ready? Okay, this is the one. We have one here in the staircase. So this area here, we plan to have it controlled under what? Dimming switch. Okay. Make sure you work in the night. Otherwise, we'll come tomorrow here and find we have gone to Arif. You'll find us too far.
Yeah.
Hmm? Yeah, I will show everything. So dimming switch. G1. Just B. Yeah. Let me share the two symbols so you can also use them. So in this area where we dining at the entrance of the room, inside this wall or here, sorry, here, So we have this one. The studio, normal switch. The entrance here should be somewhere here. Spirit sensor. Sorry? Let me give you this file. Dining switch. Let me send to you. Sorry, we will do, but let's see if we can push for the control. Then type of light, number, people can continue it themselves. I think people can do it their own. So send diming, send movement sensor, single socket. Sorry? Height, it depends on their capacity. So the protection will be 10 amps. Then you can see 10 for times 20, 30 is 50, around 500 watts or 7, maximum 1,000 of capacity. I've sent you the symbol. We have the movement sensor. In the master bedroom, we have a dining switch. But this, what we are doing for it is for the main light. If you think that you are adding another extra light for design in the room and you provide for it its own control, then it's fine also. For kitchen, we plan for we have the motion sensor in the corridor. For the kitchen we have manual. I think this should be fine now. I think we have done all the controls for this area. Hey, I'm no longer sharing my screen. I would think that I'm sure that we have covered the all possibilities. Because if you come, for example, in first floor, we have studio, we have rooms, we have toilets, we have these open areas. We know the characteristics of all the areas. It's just a matter of sitting, using what we have done as a design to put all the lights here, set up the control, make circuit, and then tomorrow morning we'll go for calculations. We'll do the single line diagram and material quantities. I will share with you this. Let me finish the region. I think we can call it a session to let people go in the rest. Right? But I wish we can work in this evening and have something presentable. Mostly for light, because other systems I think they're far. We can't. Yeah. Yeah. So let's call it a day.